Good morning, ladies and gentlemen. Welcome to the 9th CSI InApp National Student Project Awards presentation ceremony. I request everyone to mute your audio as we are starting the program. The CSI InApp National Student Project Award has been instituted jointly by the Computer Society of India, Trivandrum Chapter, and InApp Information Technologies to identify and recognize the best software project designed and implemented by college students across the country. Through this initiative, we provide a unique platform for the young talent within the country to showcase their ideas and present their project to an expert group, thus enabling rich learning through interaction with technology leaders from the industry. Today, we have gathered here to witness the final round evaluation of the 9th CSI InApp National Student Project Awards. Before we start it off, let me shed some light into the whole final round evaluation process. We started off this year's process with more than 570 projects and went through a rigorous 6-month process and shortlisted the top 15 projects. The final round evaluation is divided into 2 days. Each project team has 30 minutes allotted to them, specifically 10 minutes for the presentation and 20 minutes for the demo and the question and answer session by the judges. After this, the judges will discuss privately and score them as per the criteria. The project will be evaluated by an eminent panel of 3 judges who are pioneers in their domain. The judging panel includes, first, Mr. Satish Babu. Satish Babu is the co-founder and president of InApp. He is currently the chair of the APHELO, Asian, Australian and Pacific Island Regional at-large organization of the Internet Corporation for Assigned Names and Numbers, ICANN. He has been an IT consultant, designer, developer, and trainer for more than 30 years. He is the founding director of ICFOS, an academic as well as research institution of the Government of Kerala. Satish was the president of the Computer Society of India for the year 2012-13 and is its Golden Jubilee Fellow for the year 2014. He was the IEEE Kerala section chair from the year 2011 to 2012. I extend a very warm welcome you, sir, to the finals.
Thank you.
Next, we have Mr. Brijesh Madhavan. Brijesh is the CEO of Coverlogic Advanced Technology Solutions Private Limited and a co-founder of Nobiosis Computational Genomic Labs. His focus is to grow Coverlogics into a successful artificial intelligence company through cutting-edge R&D and developing AI product line centered around robotics, IoT, blockchain, genomics, big data, and advanced analytics. He has over 20 years of experience in advanced statistical modeling and machine learning and has held senior leadership roles heading advanced analytics, big data, and artificial intelligence teams in MNCs such as HP, IHS Incorporated, and EY. I also extend a warm welcome you, sir, to the finals. Next, we have Mr. Neelakandanji. Neelakandanji is the pioneer in the information technology industry with 35 years of experience as a developer, analyst, trainer, and delivery head. He was the past chairman of the Computer Society of India, Trivandrum Chapter, and has been an active member of the CSI Trivandrum Chapter for the past 28 years, and has served the society in various capacities of office bearer and a managing committee member. He was an invited trainer to various Asian countries on topics such as software engineering, product management, data warehousing, agile methodologies, e-governance, object-oriented analysis and design, etc. He has held positions at many organizations of national importance like Regional Cancer Center, Thiruvananthapuram. I also extend a very warm welcome you, sir, to the finals.
Thank you.
Now, let us move on and start the final round evaluation of the CSI InApp National Student Awards 2020, which is the reason why we are here today. The first team is all ready with their presentations. Inviting the team from National Institute of Science and Technology, Berhampur, Orissa, to present their project on the topic anti-theft system for two-wheelers. All the best, team. Go ahead.
Thank you, everyone. So let's begin the presentation. Our theme name is Smart Anti-Theft Vehicle, Smart Anti-Theft System for Two-Wheelers. Now I would like to request Sushma to continue the presentation.
Good morning, everyone. I am CSI from Team Embedded Minds, presenting the project titled Anti-Theft System for Two-Wheelers. Our problem statement is to develop a system that can prevent unauthorized access to vehicles, such as attempt to start the vehicle without key or any illegal movement like attempt to lift the vehicle. And the system should not only identify tampering activities like tampering of ignition wire, fuel tampering, but it also should prevent them. Apart from this, the system should also help the owner of the vehicle to monitor vehicle statistics and to track the vehicle to a mobile app. So our overall problem statement is to develop the vehicle tracking and monitoring system that detects and prevents all the illegal activities with the two-wheelers. Hello.
Yeah, we can hear you. Please go ahead.
Sorry, sir. Sorry for the inconvenience. So here is our proposed solution. So here is a proposed solution containing a complete secure system consisting of 3 interlinked subsystems. Our 3 component solutions are VTMS embedded device, which is integrated inside the vehicle and provides real-time data, and a cloud portal. So the real-time data from VTMS device is uploaded to it, and an Android app which gives instant alerts and also helps the owner to monitor the vehicle statistics as well as to track the vehicle. So now I request Harisha to carry forward this presentation.
Actually, we cannot see your presentation. There is some problem with the screen sharing. Whosoever is sharing the screen, please shut off your video and audio. Only share your screen. Yeah, maybe you should share your screen once again. We're not able to see it as of now.
Harisha, can you please share your screen once again? Can you please redo it?
I think one person has dropped off. Okay, now it's
Hello.
come back. Yeah, please go ahead.
Harisha, if you want, you can. Harisha, you are on mute. If you want, you can
Hello.
actually turn off your video so that you may get more bandwidth.
Am I audible?
It's actually breaking, but it's okay.
So here is the block diagram representation of our overall idea. So let's have a look at the front panel of the vehicle. We have implemented a case of authentication to start a vehicle. The first one is RFID authentication. The user is provided with RFID tag enabled key fob. When the tag is verified to RFID reader, the first gateway is open. Now, in the second level, we have a keypad through which the user can set his password. And finally, at the third level of authentication, we implemented face recognition using ML. The camera attached to the front panel verifies the authenticity of the reader. Apart from the front panel, microcontroller unit 1. This gives a major decision making whether to start ignition of the starter motor or not. So the first battery unit microcontroller 1. The power supply to the starter motor is initially blocked, and only after proper authentication of microcontroller 1, the starter motor runs. Next comes a VTMS device, which is embedded into the vehicle. This device consists of various sensors that detect any illegal movements in the vehicle during parking. Float sensor, which detects the fuel level during parking mode, and solenoidal valve, which automatically temperature. Furthermore, this device consists of GPS module to really track the vehicle, and SIM 800 cellular module, and the side stand and disables parking mode automatically. Additionally, we have light indicators to start to identify a vehicle identification. All the sensors are connected to microcontroller 2, which fetches data from all the sensors and writes onto the SD card, which is end-to-end encrypted. This data is then fired. So moving on to the idea flow. First of all, the customer will buy from showroom, and then the dealer will feed the entire details using the vendor software. And in the next step, VTMS device is embedded into the vehicle, followed by the installation of a VMS app. The dealer will first signed up, the user get entitled to all the services through app as well as VPN web vehicle safety. This is all working layout. And moving on to the technology stack, we have implemented fingerprint verification app. We have implemented authentication in the app. We have used algorithms to train and device for face recognition. Future, and there is inbuilt for GSM module in VTMS. We have used Arduino to program a microcontroller, Google Firebase for data logging.
Hello. Hello, is Harisha there?
Yes, ma'am.
Okay, we can't hear you actually.
Okay.
Harisha, don't turn your phone.
Hello.
If anybody else can continue, please do that. I think she's having some issue with the net.
Okay, then Mohit, turn to the next page.
Harisha, please stay in mute.
Okay, so this is the preview of our Android app, the VTMS. So as you can see, this is the sign-in screen where the user have to give email address and password to sign in. Otherwise, if he doesn't have an account, then he can go for the sign up using email page. Here, the user have to provide a profile picture and an email address and password to continue the sign up process. In order to do that, Mohit, turn to the next page. So in order to do that, he needs to provide his vehicle registration number, which we use to get the phone number and send an OTP to the phone number via SMS. So after getting the SMS, the user can input the OTP to log in. After submitting the OTP, the whole sign up process is completed and the user details are stored in the Firebase database. Next page. So here you can see the home screen of the VTMS app where the user can get the vehicle statistics. All values related to vehicle is shown in the home screen, like ignition state, battery percentage, fuel level, and vehicle stand and range status. And there are other various options like remote control, track vehicle, report theft, immediate assistance, and user documents. So these are basically the features that is used to operate the vehicle. a remote control is used to control the vehicle, like starting on or off the vehicle and turning on the EVI, features like that. And track vehicle is to know the location of the vehicle, where
You have 2 minutes more.
yes sir, where he can see the location of his vehicle. And another feature called report theft, which Google Map, which is used to open the Google Map and can see the nearby police stations. With next page. Wait. And there is another option that is called modes, where the user can select any of the modes to uh, change the current mode of the vehicle. The first mode is parking mode, another one is maintenance, and there is customization. Parking mode is generally used for the vehicle in parking mode. When the vehicle is parked, then the user can switch to this mode. And maintenance is when the vehicle is required for maintenance, where the vehicle statistics values won't be shown to the user in home screen. And another one is customization mode, where the user can change the notifications for each of the statistics values, like fuel tampering or unauthorized vehicle access, and uh, unauthorized vehicle movement, features like that. Here you can see we have four of the vehicle statistics values, which can be used to show the notifications to the user. User can select any of those values to switch the notification. Thank you.
Okay, Jagannath. Now I'd like to request Sushma to continue the presentation within 1 minute.
Okay, thank you. Mohit, turn the page. So these are the highlighting features of our system. Ensuring authentication using 3 ways provides high-level security, fingerprint authentication in app itself, and monitoring vehicle statistics in real time using real-time sensors data, and we can vehicle tracking through GPS, helmet alert and side stand alert, side stand indicator via built-in display to provide means to ensure user security, and immediate shutdown during any illegal activity with the vehicle, and unique beep sound to identify the vehicle in crowded places, reporting to nearby police stations during the vehicle theft or any other emergency. User focused modes like parking, maintenance, and customization modes, and data encryption to ensure safe data handling. Next please. So we can further extend our project by using machine learning and image processing. For example, if user is notified any illegal activity, then user can activate the built-in camera, inbuilt camera to identify who the culprit is. As well as we can extend this project to offline mode in case of poor network connectivity areas using LoRa technology. This can be further extended as an e-pass or use it to, and or it can be also used to identify authenticity of the users and authenticity of the users. As there is an inbuilt display and as well as GPS, it can be further used to suggest routes in an efficient way. So, thank you.
Thank you very much. I assume that all the presentations are over. Is that correct?
Yeah, yes, sir.
Okay. So now is the
So
time.
now I would like to show you the demo. Just it is 5 minutes. Within 5 minutes, I can show you the demo.
5 minutes is too long. Make it 3 minutes and go ahead. If you cannot do it in 3 minutes, don't do it.
Yes. Okay, just I'm showing you the only the most important parts. So this is our prototype. We had made it. I hope it is visible. Hello.
We can see your screen, but no video as of now. You can see an MP4 file in the display.
We can just see your file browser if you're showing a video.
Okay. Is it visible now?
Yes.
Hello. So this is the prototype. So this is the prototype of our. This is the display. And we have this is the camera of 2 megapixel, and we have attached. And these are the microcontrollers, RFID reader, and this is the solid state relays, and this is the Raspberry Pi. and these are the it is the overall setup of our connector. Our device is connected to a VGA connected to a desktop, and this is our main simulation program. And means if this is the simulation graphical user interface, and if we will run it, so it will start, and after we will verify it with the tag, it will authorize it. It will authorize it, and then it will ask for a pin. After we will enter the pin, it will go for it will go for authorization. After the face authorization, it is authorized. After it is authorized, it will start. It means it will show it that it is start, and if we will start the vehicle, then it will start the vehicle. And similarly, we have one unauthorized video also. So means some other video, and it is if we will play it, it will, if we are by executing it through command prompt, it won't, means it won't start. I mean, it won't start the video, and it will unauthorized. It will unauthorized it. So this is the saying it is unauthorized. I have given the Sushma face train it through Sushma face, so it is showing unauthorized, and my face it is showing unauthorized. So this is and if it is unauthorized, if we will start the vehicle also, it won't start. So this is so so this is if we will touch from vibration, if any circuitry damage is there, a notification is going to trigger. And see, this is the vibration detection. This is the part of our microcontroller. It is detecting all the microcontroller vibration, and this is it will real-time updates all the GPS module and everything. It is showing real-time updates to the Firebase. So uh, and it is for the stand. We have applied one IR stand, and this is if I'm changing the orientation of the vehicle, then also a notification is triggered. So this is remote control mode of the vehicle. We can start and stop with no need of any authentication, just opening the app and ignition on and off. And also we have included a feature of EVI, so it will on the lights of the system, all the lights we have applied. So this is the, and this is the solenoid valve. So this is connected to the fuel tank. We can, in if we are parking it, we can switch off the fuel tank. It will stop the fuel passage to the engine. And yes, then no, the vehicle won't start without fuel engine. This is the demo. Hello.
Yeah, thanks. Is there anything else you want to tell us before we go into questions?
No, sir. This much is enough.
Okay, so I think we are having audio problems. So I would advise that all of you turn off your audios and videos. We don't want the videos at all now.
Yes.
So when the question is asked, the person who's speaking, please turn on the audio. Others remain muted, please. Is it okay?
Yeah, sure, sir.
Right. So my name is Satish, and I'll ask a question first to just get started, and then my colleagues will also have their questions. So my overall comment is that this seems to be a fairly complex piece of work for a two-wheeler. And as far as the two-wheeler is concerned, the changes required to install the system is kind of invasive, meaning you have to change too many things at too many places. This is my impression. So, for example, if you do that, the warranty of the two-wheeler will become invalid because companies don't permit so many modifications to their two-wheelers. Do you think this application is overly complex? What's your opinion?
Yes, sir. I got the question. Sir, actually, means we want this system to be a, means as a already implemented by a company. So we want it to hand over this system to a company so that it can embed this device to the pre-embed this device while manufacturing, so that a mere 2,000 extra and 4,000 or 2,000, 3,000 extra, it will increase the security of the vehicle, as our main focus is to notify the user anyhow about the security of his vehicle. So 2000 extra, I know it will be little complicated, but it is not that much complicated, as just all this system is looking very complex because we have made it such as a demonstration. Means we have included the fuel tank, and we have included that solenoid valve, but just applying the solenoid valve between the fuel means engine and fuel tank.
Yeah, go ahead. I think you got cut off.
Okay, I would like to add a point to it. Since this is a prototype, it looks little bit complex. But when we talk about the real-time implementation, in VLSI scale, obviously it will look simplified.
Okay, so if you're thinking of making this standard part of the two-wheeler by handing it over to the company, there are actually for a industrial product there are several more constraints. For example, safety is number one. Is there anything that's unsafe in your overall architecture? So the considerations become somewhat different when you are thinking of an industrial application. Uh, but that's my comment. I will stop here. My colleagues can raise their questions. Please go ahead.
So, Satish, can I ask? This is Brijesh.
Please go ahead, Rajesh.
Uh, Hi, team. Nice. I think you put in a lot of effort and also in implementing this, right? But a couple of questions I had. See, you have this component called remote control, right? And you mean it's primarily, let's say your vehicle is lost and then you want to shut it down remotely. Isn't that the purpose?
No, sir. We are not implementing in that way. It is for only, it will, the remote control. Hello?
Go ahead. Go ahead.
So it is not in that way. It is only the remote control will work in 200 mode. Due to security issues, we haven't linked it with, means if the phone is lost and by chance if the user gets the, someone gets to the access to the app, then he can control through remotely. So we have disabled this feature. This is for it's like a key fob we are using in a car. Similarly, we can use the phone when we are in the range of 200 meters from the vehicle.
Okay. So, but still, it could be a security. Good that you thought through that, right? So my question was actually around the answer that you provide. Good that you thought through that. Sorry. And one last question I had. See, this like Satish was saying, this looks overly complicated. Too many components there, and we also understand that this is a prototype. It could be bulky, but too many components there, and there can be many points of failure, right? And so that is one feedback I had. And the other one is, so you said you did machine learning, you did face recognition, right? What did you use there? What kind of software did you use there? What kind of what was the gap that you saw? You said you used Raspberry Pi, right? What is the gap that you saw? We really could see Sushma's face being identified, but what is that you use there? And what was the constraint that you
Actually, sir, actually, hello, is it audible?
Yeah, go ahead.
Hello. Yes, sir. Sir, actually, it was actually the Sushma's face. I'm playing. I'm giving a .mp4 file as input, and it is authorizing. Means there is a video capture in OpenCV library. There is a video capture option. If we will set it to 0, then it will record through the webcam I have implemented in our device. So actually, due to this due to demonstration, means because I want to demonstrate, I didn't put that 0. I just played a MP4 file and it reads that MP4 file and it authorizes or it authorize it. So if I will set it to the camera, then it will verify in real time through the camera. But due to problem in demonstration in recording and all, so I made it to .mp4 file and played it and then verified it.
when you did that with OpenCV, right? The biggest challenge you would have
Yes,
seen
sir.
is, you know, when you showed your face, sometimes it detected as Sushama, right? And when Sushama showed her face, it detected as someone else. Did you ever face that problem? Right? Because that,
Yes, sir. Actually, it
how
depends
did you?
upon the data sets. I mean, how much we are training it, the confidence percentage is increasing, and then it is verifying it. Then it is matching it.
What data was that? Like, is the same person's data, or should it distinguish from others? If it is others, you can't have the data there because it's someone else's face, right? How do you solve that
Uh,
problem? Right? Have you thought through? We don't have time, I know, but if you can say, summarize that in like a 30-second thing. Have you thought through what goes into it? What are the challenges, etc.?
Sir, actually, this LBPH algorithm, local binary pattern histogram, algorithm. This one is creating little issues, but I had made the mean system such a way that any algorithm can be implemented in that place. Because more
That is the
efficient
challenge.
algorithms are available than LBP8.
Yeah.
Hello.
So the challenge is you can use something very light, or then you can use heavy, and then Raspberry Pi is not sufficient. You understand?
Yes,
Okay.
sir.
Yeah. So anyway, good. I think that's all I had. Good work. I think we put in a lot of effort for sure. We could see that at least in the hardware, at least pictures, we could see that, and it looks like you spend some significant time in. Okay. So did you guys use Python, or did you use C++ for OpenCV?
Sir, OpenCV, Python. I have used Python, sir.
Fantastic. So when it's industrial equipments, or it's components like that um, for vehicles, for a prototype it's okay, but I think when you really want to take it to the next level, doing
Yes,
things
sir.
on C++ is a good idea. Okay, thank you.
Yes, sir. Rest all the embedded device means the sensors, equipment, all are programmed in C, sir.
C++. Yeah,
Only the OpenCV.
I understand.
Yes, only the OpenCV I had used in Python platform, sir, because it is easy to implement in Python.
Very good. Thank you. So
Yes.
thanks you. Thank you. Overall, I felt it was good effort. Thank you.
Thank you so
So
much.
thanks for that. Neelakandan, you have any questions?
Yeah, it's a good presentation anyways. So I have one doubt here. Is there anything that you have taken care of so that the entire system, the security system will not be tampered with? That is, the entire system as it is not taken away from the vehicle and before it is being lifted or something.
Sir, I couldn't get the question. It is
Okay.
not.
Say in your presentation, you said that, okay, even if it is not, the machine is, nobody is trying to switch on the machine, but it is being lifted and taken away. There is a system for identification of that kind of an incident, right?
Yes, sir.
Okay. So
Yes, sir.
similarly, is there any chance that the entire, this device itself will be tampered with or taken away from the system, or how you are planning to make it fail proof?
Sir, actually, once if it is locked, means when we devise a VLSI architecture, when we give it to industry for PCB manufacturing, then that time there is a vibration sensor means applied. That vibration sensor won't give normal values, means won't that it is not that much sensitive that if the vehicle at all together move, it will give vibration. Means it will give a notification. But yeah, if the circuit is touched in anyhow, then there is a spring in the vibration sensor which will give ADC analog values. That analog value will trigger a notification, means that will sense that there is a change in tempering in the inside circuitry. So in that way our circuit means anybody who wants to temper the circuit, they can temper the circuit. Anybody, if they try or they attempt, then they will the user will be notified that yes, there is a tempering of the circuit occurs, like that. Tempering of the circuit is detected, like that.
Okay, so it's a kind of burglar alarm kind of things are also a part of that. I mean,
Yes, sir. It is fully fledged system. Means if anybody wants to change the circuit, then also not. It is a three-way authentication. Means for RFID, if RFID is breached, also we have alternative as PIN. If PIN is also breached, we have face authentication. Although face authentication will be little problematic. Means the algorithm should be that much strong. We need to means now we have used the default algorithm by the OpenCV, but if we will change the algorithm and we will means we will implement a strong algorithm, then sure it is foolproof and unbreachable system.
okay, thank you. Yes.
Thanks for that.
Yes,
So
okay.
overall,
Satish,
I'd like to
can
thank. Sorry, you go
can I
ahead.
can I
Yeah,
ask
go
one
ahead. Go ahead.
last question? Uh, so see, you said you kept saying real time, right? Um,
Yes, sir.
is anything stored in the device at all? Is there anything stored in the device?
Sir, stored is the state, present state means in the remote control. Means in the remote control, the state means if we put it, means if we
On
put
the
the vehicle to ignition on.
Yeah, on the
Hello.
device, the whole unit that you're attaching to the vehicle, in that, are you saving anything? Or
Yes, sir. Yes, sir. The relative path to the Firebase database, the vehicle number itself, and
my,
all that in an encryption form,
yeah,
encrypted form.
my question is, when you are not off the grid, if once you're not, your network connectivity is poor, let us say, what happens?
Yes, sir.
Have you thought through that?
Sir,
So
it
both in
heavily
terms of
depends upon.
both in terms of OTP one, and other one is streaming data, right? You're streaming data to iOS databases and all of those kind of things, right? Uh, what
Yes, sir.
what's happening there? So have you thought through that, or do you have something like a local database on the Raspberry Pi itself, and then do you
Yes, sir.
synchronize it and all of that? Have you thought through them?
Sir, already the device won't fetch from Firebase until unless it is means Firebase unless it is not connected to the VTMS local Wi-Fi. Means if it is disconnected from the local Wi-Fi of that vehicle own hotspot, then it will fetch from Firebase real-time database. Else it won't fetch from. So this is what offline mode means. If the user is within the range of 200 meter, then the direct values are going and means are getting updated in the phone. So no
Okay,
need of Firebase at that time. So
okay,
it's like
thank
means real time. There is no local storage available.
you. Okay, good, thank you.
Yes.
Thanks very much.
Thank you.
We have run out of time now. I
Yes.
wanted to ask a question about uh, the power consumption of the entire thing, because it's always on, and also using the
Yes. Sir.
Wi-Fi, GPRS, and all that, GPS
Yes, sir.
also,
Yes.
and the entire power is likely to come from the vehicle's battery, which in turn is coming from the petrol or
Yes.
the engine of the vehicle. So, what is the
Yes.
impact on fuel usage? But we don't have time to take this question. I just wanted to flag it. So, thanks very much for your effort. We will get back to you with the next steps.
Yes. Thank you, sir.
Thank you.
Very well presented, team.
Can we
Thank you
exit
so
now?
much. Yeah. You can exit now.
Thank
Thank
you.
you so much.
Thank you.
Now we are having a discussion session privately for the judges, and the next presentation will commence from 9:45. Hi Karthik, is everybody in?
Yeah, hey, yeah.
No, two more people have to join.
Okay, okay.
Also, the thing is, I joined from my phone to show a demo for something, so I can't see the share option on my screen share thingy on my phone.
Okay, okay, let me check it.
Yeah. Oh no, I got it. Fine. Got it.
Yeah. Yeah. Where is the other two people? Are they? No, right?
Yeah, they're joining. Just a moment.
Okay, after you start the presentation, if you have any problem with the network issues, please turn off your video, okay?
Cool. Okay, so one more joined. The thing is, I have put up some links on the chat. So these links can be used to check out our deployed web app on our website, and also a few more things that might be useful during the presentation. So this can be used by the panel members. So one more of our team members joined. The third one's joining. So yes, we'll wait for like a few more seconds.
Just intimate me after everyone has joined.
Okay, cool. Yeah.
I think everybody is in.
Yeah.
Okay. Now, I welcome the team from Rajagiri School of Engineering and Technology, Kochi, Kerala, to present their project on the topic cold blocks. All the best, team. Go ahead.
A very warm welcome to the esteemed panel members. Let us start by understanding a cold chain network. Now, cold chain denotes the series of actions to maintain a product within a specified low temperature range. Or in simple words, is it a supply chain with low temperature constraints? Now, does the delivery time parameter gets affected by both refrigeration cost and the cargo damage cost factor? Now, what are the risks that are involved in a cold chain network? An unsafe product can be administered, and not complying to the prescribed temperature can produce adverse effects. Inconsistency of results by thermal variability and huge delays and monetary loss may creep in if the shipment does not satisfy the quality standards. Now let us analyze the problems that are being addressed by our product, cold blocks. As of now, there is no quality assurance from a customer point of view during transportation. For instance, consider the case of insulin. The expiry might be printed as, say, May 2022. But if it is not kept under prescribed temperature during transportation, the quality deteriorates. And this is a simple example of how expiry date provides misleading quality assurance. Moreover, there is no single app interface that logs the transaction of every relevant actor of a cold chain. Thus, uncollated and unorganized data is a huge anomaly. Now, one of the subsequence of unorganized data is the blame game that goes on between the actors. Once it is diagnosed that the quality of the product is compensated, the actors tend to blame each other for the mishap. Since cold block is not merely a conceptual theory and is also based on current issues, we have some statistics that back up our motivation to engineer this product. The Asian Age reports that in India, more than 30% of fruits and vegetables go to waste due to poor energy infrastructure. In fact, in India, only 8% of the produce is actually processed. Now, this number is huge for countries like Vietnam and Brazil, where a major fraction of the hunger problems can be eradicated. Now, the subsequence of the problem can also be life-threatening. In August 2017, a shipment from a lot of intralipid 20% IV fat emulsion of Baxter International Incorporate was improperly exposed to a sub-freezing temperature on its way to a distribution facility. The company voluntarily recalled the parental nutrition product about 2 months later, but then it led to a loss worth $20 million for the company. Now, this compensated product could have even led to fatality due to the obstructed pulmonary circulation, and this incident, as we said, led to a loss of millions of dollars. Now over to Daniel for the objective. Daniel, you're mute. Daniel.
Okay. So coming to the objective, our main objective is to provide quality assurance to all our customers. So in view of cold blocks, quality assurance means whether the product is of optimal quality to use or not, and if it was transported in optimal temperature. So to secure the supply chain, we use a decentralized record management system to store electronic transaction records, giving priority to mainly security, quality assurance, and real-time data availability. So at this, the consumers are also at a great advantage with our product, as the quality of the product can be assured using our product, Cold Blocks. Now over to Karthik.
So coming to system architecture of cold blocks, we have modularized the entire project into 5 main modules. We have a physical layer or the IoT layer, which consists of the temperature and GPS sensors and which transmits whatever data like temperature and GPS data over Wi-Fi using a Node MCU module. So that is layer one, which is the bottommost layer. Then we have a Node.js backend layer, which is basically a middleware because we did not want our blockchain layer to be publicly, the blockchain APIs to be publicly available. So we used a Node.js middleware, which acts as middleware for all the transactions that happen to the blockchain, which is either read or write. So it validates all transactions. Then we have encryption from our physical layer. So whatever data is sent, like temperature, GPS data, and along with package details, all of those are encrypted using an encryption algorithm called AES-256, which is done in the Node MCU or the hardware code itself. The reason being, we wanted to nullify or we wanted to cut down all chances of a man-in-the-middle attack in that portion of the network. So we have decryption on the Node.js layer, and then we have a notification stream which is using WhatsApp. So that also comes under Node.js because we are using a Twilio WhatsApp integration. And then we have reverse view encoding. The reason being that we are getting coordinates from our hardware sensors, and we do not want to print out the coordinates as such. And that's why we use reverse view encoding to convert or map those coordinates into real life addresses for better user feasibility and user friendliness. So then comes a Hyperledger blockchain layer. So this is the heart of the entire project. It's our entire log of transactions which have happened throughout the blockchain network. We have a smart contract which supposedly is called chain code for Hyperledger. Then we have a consensus manager, identity management, and of course we have an API interface, which is basically all the get, post, put handler, which is all REST APIs. And then once again, we have a Node.js layer. Like I told you before, we are not making a blockchain layer publicly available to all users. So this particular Node.js layer acts as a middleware between our front-end web app and our blockchain layer. So it does the same thing which it did before. So we have decryption, we have API interface, we have WhatsApp notifications, and we have reverse view encoding. So, and then coming to front-end web app, basically it's the web app, PWA, progressive web app, which users can use to interact with our entire network. They can check out the logs, they can create consumers packages, and we have a few data visualization tools as well, which I'll be showing you during the demo. Now, okay. So now over to Jim for the module split up.
Okay, so ma'am, as you can see, we have in total of 6 modules. So first, starting with the first one, that is the hardware. So we have a temperature sensor, that is the temperature and the humidity sensor, that is the DHT22. We have a GPS sensor, which is uBlock's new 6M GPS module, as well as we have a Node MCU for the connectivity. For the backend web server, we are using Node.js as a backend, and it acts as a middleware. It mainly has 2 main functions, that is the reverse view encoding, which basically converts the coordinates into its particular location name. And we have the Twilio integration, which is basically the WhatsApp integration, which sends notification to our WhatsApp. For the blockchain, it basically stores used for the secure log of data. It has the distributed ledger, and it has REST APIs, which is used for methods such as the get and the post. Now for the front-end web application, we are using React.js, and we have a user interface for all the users. We have a single web app interface, and we have a dynamic QR code rendering. For routing, the optimal routing for the VIP, that is the vehicle routing problem, is using Google Auth Tools, Google Maps, and the distance API. So here we have the location will be, we have the location, and we can find the distance using the distance metrics. Then for the notifications, we are using the Twilio WhatsApp integrations that as I told earlier, that basically a notification will be sent to the WhatsApp, and we have a AR enabled QR code for status check, that is if a product is tampered or it's okay. Now Daniel will talk about the risk and challenges.
Yeah, coming to risk and challenges. First one is seamless connectivity with supply chain. So a typical healthy supply chain is a supply chain with full-time network connectivity, but it is known that that's not possible due to geographical and various other reasons. So the Wi-Fi connectivity is bound to get disconnected at some point where the customer will not be able to get the live update. Then pressure to meet cost efficiencies is technologies nowadays might be too expensive. So the transport providers are making to do with what is just enough. And supplier risk in your cold chain means that the product might already be of bad quality or the spoiled raw materials to begin with, even before it's packaged. Then it might be because of dodgy relationships with suppliers, which could lead to less than ideal handling of the goods. And environmental impact means there might be many factors which might affect the cold chain network due to the environment. And distribution and delivery is packaging failure, hardware failure, and vehicle or model breakdown are very commonly seen, and that could compromise the product quality. Kevin, you're mute.
To conclude, the merger of coal blocks to the existing cold chain network is a promising endeavor, as we believe a product has the potential to transform the whole supply chain scenario. With the incorporation of cutting edge technologies in the most thoughtful manner, we believe that our product emerges as a solution to the current issues and problems that were previously unsolved and to a large extent ignored. In short, we believe coal blocks possesses the ability to enhance the existing system for the cold chain management and to revolutionize the legacy problems that always overlaid the cold chain networks. Now over to Jim for the future enhancements.
So our product Codeblock as of now is a single organizational structure, and we want it to be a multi-organizational structure. We will use machine learning or data analytics to provide a comprehensive analytics of data, that is to infer out the most important data, since there will be a huge data set. We will use native apps such as the Android or the iOS app in place of a progressive web app that we have made. We will allow Google authentications or other techniques to access the network. And we will include different stakeholders, insurance companies, to access the whole organizational network.
So coming to demo, I'll show you the demo right now. Also, the link to the demo has been shared on the chat window. So any of the panel members can log in using these credentials. Also, our project has been made public on GitHub, and it has been hosted via Netlify on a custom domain, which I have provided you on the chat window. So that's all for the presentation. Now I'll be moving to the demo part. So for demo, I'll do half of the demo on my laptop, and for one particular event, I'll be using my phone. So I'll be switching to my phone in between. So at first, we have our Fabric server running on the terminal. So it has been running since quite some time. So I last switched it on about 10 hours ago, and it was first created about 2 months ago. Then this is my Composer API, which has been set and is working. Then I have my Node.js backend server, which is running. I have my React, and I also have my routing, which is being done right here. So I just switched on my Flask server for routing. So we already have a Node.js backend server. We are using a Flask server as well, just for our routing problem, because we are using a lot of external APIs for our routing problem. And we did not want those external APIs to affect or hinder our Node.js backend server, which acts as the hard server for the entire network. So now coming to the, okay. All right. So yeah. So this is how our basic dashboard looks like. So this is the login screen. So as soon as you come to cold-coldblocks.tech, this is the dash you would see. So every user has his or her own user credentials, but the admin has user credentials, say admin and admin. So when we log in using admin credentials, you will be routed to your dashboard. So you have a few dashboard customization options. Except for that, on the dashboard, you have a basic user details. You have a package status card, and you have a package data card. So basically, this card gives you an overall look about your packages, like all your packages under your organization, which are being routed, and the status of all those packages. And this particular field allows you to test those packages to check if they are tampered or if they are of status okay. So So now coming to Cold AR. So Cold AR is basically what I told you was the dynamic QR code rendering component. The use of this is in our blockchain network, we have majorly two transactions. One is a temperature drop transaction. The other is a holder change transaction. So the temperature drop transaction, as we all know, is basically when a particular consignment or a package is not being transported under optimal temperature conditions. That is, suppose the threshold temperature for a package was say 10 degrees, it was being transported at 20 degrees. That's when the temperature drop transaction occurs. The second important transaction which is defined in our network is the holder change transaction. So basically, holder change transaction is the transfer of package from one holder to another. So to simplify the entire process in a huge supply chain network where we would have a lot of holder change events throughout the transit of a package, we have used a holder change event which is triggered using a QR code. So from an admin point of view, when I am the admin of an organization, I would be really happy if I could dynamically render QR codes. As you can see, as I'm changing the package IDs, I'm dynamically rendering a QR code. So all I need to do is I need to download it, which is downloaded in my on my desktop right now, and I can print it out and affix it on top of my package or consignment, which is being transported. And different suppliers, manufacturers, consumers, and distributors can scan this QR code to do a holder change event. So for this particular event, I'll be using my phone because I need to scan the QR code. Then comes package data. So package data is basically gives you an overall view about all the packages. You can query a package and you can create a package. So I've already created, say, about 5 packages here. So out of which 4 of them are tampered and 1 is not tampered. So I had already mentioned before in the Google form that we had our hardware, but since our hardware is at college and it's not physically possible to vary temperature, we would be simulating those API using a tool called Postman. So I'll be showing you that later. So for now, we'll create a new package, say ID at 006. We'll give destination as RSET, holder say as 01, and the threshold temperature says 10 degrees. So when I press submit, I'll be getting my request to be first going to my Node.js layer, which would then be forwarded to my blockchain network. And then I got a response back saying that, okay, I got a status code which says 200, which means the transaction was completed successfully. So if I check now, a package at 006 has been initialized with package holder S01, a threshold temperature of 10, the destination is RSET, and package status is okay. Now we have 2 fields which are undefined. Basically, these fields would have the values from the hardware sensors, that is real-time location and temperature data. This part we will be simulating using Postman. Like I said before, we would not be able to physically change the address or the temperature. So that's how we're going to simulate it. Coming to the next part is query package. Query package basically allows an admin to query all the packages with respect to different fields. So basically, he can query a package with respect to destination, holder, location, and status. Basically, this has been made in view of a big organization where you would have thousands of packages. So you might want to filter out those packages using some particular field or some particular criteria. So this filtering is done using Lodash. So at first I'll show you using a querying using holder. So when I press S01, okay. Okay. Fine. So I'll put S01, I'll press submit. Okay, fine. So all the packages which are of package holder S01 have been printed out right here. That's because I gave I queried all packages with package holder S01. Similarly, let's try to find out all the packages that are tampered. So if I put tampered right here and if I press submit, you will see that all the packages that have been tampered have been found out. Similarly, let's do it for destination, say QSAT. So if I put in QSAT, I'll filter out all packages that are going to QSAT. So basically, this allows an admin to filter out packages more easily and find out the details about it. So then comes transactions. So this basically is the historian log of all the transactions that have happened in the entire blockchain network. So there are a lot of transactions, and basically I have kept a field which allows you to filter out those transactions once again for better user friendliness and user feasibility. So I can, of course, filter out those transactions. This filtering is also done using Lodash. So as you can see, you can check out all the add asset transactions that I have done inside my entire network, along with the person who did it, which is admin, and the timestamp. So as you can see, June 20th, 9:59, which is the time right now, I created a package. So that is this particular log right here. Then comes a set of 4 components, which is consumer data, distributor data, manufacturer data, and supplier data. All of these 4 fields or 4 components basically allows an admin to create, view, or edit a consumer. So I'll just show you for one consumer, so because it's the same process for suppliers, distributor, and manufacturers. So we'll create a new consumer, say 303. We'll name it as CSI, and we'll give a password 1234, and I'll press submit. So this details is first sent to my Node.js layer, which is then forwarded to the blockchain network, and I got a status code of 200. So which basically means I created a new consumer which has name CSI and password 1234. Now, one thing to be noted is to enhance the security, what we have done is the password is always SSH-256 encrypted. As soon as it leaves the front end, it is encrypted and then it is sent to our backend servers. So throughout our network, the password is SSH-256 encrypted. So I'll show you a querying also. So we'll query the new user we just created. If I put C03, you'll find that the customer with customer ID C03 was found with name CSI. So I'll also show you how an edit looks like. So I'll just change this to Computer Society of India and the password 1234. So if I press submit, a put request should happen right here and it will allow me to edit the details of the actor which I just created. So as you can see that now the name has changed to Computer Society of India. And now if I run the query once again, you'll see that the name of the customer has been changed to Computer Society of India. So basically, from an admin point of view, if I'm the admin of an organization, I have the access or I have the right to create consumers, distributors, manufacturers, and suppliers, to query them, and also to edit the details such as name and password. And also the same goes for package, but you don't have an option to edit package details. So as I said before, it's the same for distributor, manufacturer, and suppliers. You can create all these supply chain actors and you can edit those details. So then comes holder change event. So basically this is the part which I will be showing you after the entire demo. So like I said before, what is a holder change event? It's basically the transfer of package from one holder to another, say supplier S01 to manufacturer M01 to distributor D01 and then finally to a consumer C01. So this basically
your time is running out. You have another 3 minutes to go.
3 minutes. Okay, yeah, cool. Okay, so yeah, this is the holder change event. Then we have optimal routing where you can route those packages using some particular location. Then you have data visualization, which allows you to check, which allows the data analysis part. Now I'll show you how a temperature drop event basically occurs. So in my package data, the new package which I just created has a threshold temperature of 10. So I'm going to use Postman, the tool, to simulate an API for temperature drop for a package at 006 with temperature say 20. So when I press send, and also at the same time, I'll update the package details to at 006 and 20. So I press send, and if I check out my package data now, it will be tampered. Now, as you can see, the package data has been tampered. The reason being the threshold temperature was 10 and the live temperature that I passed was 20. The address which comes out automatically is our college. The reason being that we used the hardware for the last time at our college itself. So it's using the same coordinates again. So then comes optimal routing. So yeah, cool. So like I can provide any kind of so I'll use the data set which I had already created and which I've already used from our GitHub repo. So this is the particular, we have used data set from Bombay. So I'll just press submit, which will send a request to the backend and which will reflect on our front end. So yeah, okay. For some reason it's not.
Okay, wind up now.
Okay, yeah, cool. Yeah. Okay. So,
yeah, thanks for the presentation. And I think you have done a lot of work. Congratulations for that. I'd like to know what version of Fabric and Composer you're using.
We are using Composer 0.20 and Fabric 1.4.
1.4.
Yeah, I'll just cross check because
Are you sure about that? And why are you using Composer? Composer has been obsolete since August 2019.
Yeah, the reason being that we started our project back in June. So that was when we started with Composer. And then it became depreciated. I know we have changed to Convector, but since we had kickstarted our project using Composer, we went with the idea of going with Composer. And then once our project was entirely complete, we had an option of changing to Convector. But then we went on with Composer and Fabric, and then we integrated the entire blockchain network to our front end and our back end. So we did not like.
I'm sorry, that doesn't sound really correct, because you have had 1 year to shift, and you are still stuck at a dead end. Can you tell us something about, very quickly, because we don't have time, about your Hyperledger network? What sort of network is it? How many peers? What sort of layout do you have?
Yeah, so basically a Hyperledger network consists of 4 major peers: suppliers, manufacturers, distributors, and consumers. And all those peers have, and it all comes.
Hang on. So you're saying that you have distributed the peers, and you have basically called them supplier, manufacturer, and all that. That is not
No,
the way
basically,
Hyperledger usually works.
Yeah, exactly. The thing is, since we are using it on a single machine right now, we have a single peer, because this is not
okay, you have a single peer. That's enough. Okay, that's fine.
That's what. So
you
this
have
is
a
not a
single
production
peer running the whole network. And I see that some of the major parts of your projects have been left unaddressed. For example, the refrigeration system is on some moving device like a truck or a ship, like a reefer container. How does the communication take place from the Hyperledger nodes, the peers, to these moving things? We didn't see anything mentioning how this communication was taking place.
Yeah, so that's what I mentioned in the physical IoT layer. So basically, the communication happens over Wi-Fi using a Node MCU module. So whatever data is being transmitted from our package, which is temperature and GPS data,
over Wi-Fi from a truck and a ship.
Yeah.
Really?
Node MCU module. Yeah.
Okay, I will stop here. My colleagues can ask questions.
Sure.
So. Just continuing with the question, right? So Wi-Fi. So did you mean like a ship has its own Wi-Fi and the immediate connect to Wi-Fi, and then something else like satellite or what?
Yeah.
Okay. And you also said something around I couldn't hear clearly. I'm not sure if you said Node.js or Node MCU, right? In Node.js, I think you said Node MCU, and then you said some encryption part there. Can you just elaborate more on that?
Yeah. So Node.js is a basically backend server. What you said was right. We have Node.js as well, and also Node MCU, which is a hardware part. So for Node MCU, we are using
my point is I couldn't really hear what you said.
Yeah, sure.
And at that time, did you talk anything about Node MCU and encryption?
Yeah, we have used a library called AES-256lib, which encrypts our data using AES-256 encryption, and that data is being transmitted over Wi-Fi to our Node.js backend server.
Okay. Thank you.
Yeah.
And how much of what you have done? It looks like you put in a lot of effort. 1 year consistently. I just looked at your Git repository as well. How much of it you could leverage directly from the Hyperledger publicly available source and examples there? How much of it was yours?
Our React.js frontend, our backend server, our optimal routing, and blockchain. Even though we have the documentation completely, we have written our own code for the blockchain Hyperledger part as well. So our entire React.js frontend framework, and we had a particular admin UI which is created using Angular. The Python code for routing and our backend server is completely ours. We have also written a paper on it, which has been accepted but not been published as of now.
Yeah. So you said you are using OR tools with Google Maps.
Yeah, OR tools. Yeah.
Can you just elaborate a little more on what you did?
Oh, yeah. Okay. So the thing is, I kind of ran out of time, even though it started at 9:45. So basically, we're using Google OR tools to provide optimal routing to suppliers, manufacturers, distributors, and consumers from a vehicle routing problem. So the reason being that we did not just want to provide quality assurance, we also wanted to provide a subsidiary feature with our project, which was optimal routing. So that's why we use Google All Tools, which does VRP using a greedy distance strategy and the cheapest start first method. So basically, if you provide the number of vehicles and a set of addresses, if you have a Google Maps and Google Distance API, you can calculate the distance matrix dynamically, and then you can do a VRP solver on that particular problem.
Okay. So, and this is primarily for like a trucking company, right?
Yeah, because since its cold blocks is basically on a logistical field, we already thought that we would have trucking movements as well as small vehicular movements. So this is basically routing for all those organizations that would require any kind of roadways or road movements as well.
Okay. So anything else? Yeah, maybe you don't need this like ships and stuff like that.
No.
Thank you.
Okay.
Yeah,
so,
go ahead.
I have a question. So you said that it's about transporting things which are to be refrigerated. Okay. So as of now, there are quite a lot of containers which require. There are containers with refrigeration is also there, already there, and of course there must be sophisticated systems with the all data collection kind of black box or online, maybe kind of online or real-time kind of data transmission. Everything that should be there, I believe.
Yeah.
So if that is true, then where your system fits in?
The thing is, we have a lot of tools that allow us to keep a log or a history of whatever has been happened, but we can't say that all of them are totally accurate or error free, because anyone with an evil mind could always manipulate the data to his or her own positive motive. For example, if I am the supplier, and if some part of the package was under, say, non-optimal conditions, then I can always manipulate that data to show that that particular movement of package under non-optimal temperature did not happen under me, it happened under someone else. So to make sure that that particular scenario doesn't happen, and also us as end consumers, like when we go to a clinic, or when we go to, say, a pharmaceutical store, all we do is, like we mentioned in our problem statement, we always check the expiry date, and we never know how well or how what the quality was during transportation from the supplier till the end consumer. So once I procured the raw materials for, say, insulin, that is A, B, and C, I don't know if that raw material was transported under optimal conditions. All I would know is, okay, the expiry date is 3 years from now, so it's optimal to use. So these two factors are the major things that we worked on. One is to keep a secure log of transactions, which is non-updatable, even though it can be, we have a history of it. The second part, allowing an end customer to have a transparent view of the entire supply chain network.
Okay, so you mean to say that the end customer can use that code printed or QR code printed on that system?
Yeah.
So you mean to say that for every, okay, you said the example of insulin. So every insulin injection bottle vial has got a QR code or that kind of a code printed, so that I can check that.
Yeah, exactly.
Okay, thank you.
Hey, I have just one more question. What is the sensor that you use? Did you say DHT11 or I'm sorry?
Okay, I would request Kevin to take on, because he was
The
the one
sensors
for
used
hardware.
are DHT22 temperature sensor, temperature and humidity sensor, and Neo 6M GPS module.
Okay.
These two for like, yeah.
So, and when we're talking about cold chain, it's sub-zero also, isn't it?
Yeah.
Our threshold temperature can vary from sub-zero to any positive temperature. Even though I gave an example of 10 degrees, it could be -20 or -30.
Yeah. So the problem there is DHT11, DHT22, all of their ranges are 0 to 50 degrees. They're not meant for sub-zero as such. At least as far as I remember, I need to just go and look at the data sheets. But have you thought of that?
The reason being, we use DHT22 sensors because our motive or our basic hardware to go for was a particle photon, which basically has IoT and Wi-Fi connectivity along with all the sensors and Bluetooth So that was our go-to option for hardware. But because we had constraints for funds and because it was a project, we went for DSC22. So our go-to hardware was a particle photon, which has an integrated IoT, Wi-Fi, Bluetooth connectivity along with all those sensors. So that was our go-to hardware. If this thing was ever to go to production, we would always use something, say a particle photon.
Right. Thanks very much. I think you have to work on your time management because you were given exactly 30 minutes for the entire thing from 9:45 to 10:15. So we have overshot a little bit. I think it's a good project. It is very similar to what Maersk has implemented in 2019 in their global shipping reefer containers. There are some practical issues and gaps that we see, but maybe it's worth working on for further. So thanks very much, and you can disconnect now.
Okay.
Thank you so much, team. You may leave now. We will be having our next presentation at sharp 10:30.
Hi Tanmay, is everyone in from your team?
Oh yeah. Sanket is still to be joined.
Okay. Just
Waiting for
inform
him.
me, okay? And everyone else has joined.
Yeah. Yeah, he's here.
Next.
Oh, just a sec.
Are you all ready?
Yes, ma'am, we are ready.
If you have any problem with the connectivity, please turn off your video, okay? While presenting.
Yeah, sure.
Judges, can we start?
I think we are ready.
Okay.
So just inform them of the time that they have.
Okay. Guys, you have 10 minutes for the presentation out of the 30 minutes, and rest of the minute is for the QA session and the demo.
Okay, yeah, sure. So, should I start?
Just a second. Next on this schedule is the team from PS Modern College of Engineering, Pune, Maharashtra, presenting their project on the topic Detection of Wormhole Attacks in Wireless Sensor Networks. You can go ahead, team.
Oh, yeah. Share the screen. Gautam?
So, good morning, judges. My name is Gautam Nair. We are from the Modern College of Engineering, a group of 4 members, Sanket Jankar, Atharva Joshi, and Tanmay Negoskar. So, initially, I would like to express my gratitude towards the panel of judges for giving us an opportunity to present our project at this platform. So, our project is NRIS, a novel-based hybrid system for detection of wormhole attacks in wireless sensor networks. So, basically, what's a wormhole? A wormhole is an out-of-band connection between two nodes using wired or wireless links. In a wormhole attack, the two conniving nodes tunnel control and data packets between each other with the intention of creating a shortcut in the wireless sensor network. The attackers strategically place themselves, which results in disrupting most of the routing tables. Generally, this type of attack is launched by two or more malicious nodes having a channel, a private channel called a tunnel between them. As I said, the attackers put themselves in a powerful strategic place in the network. They actually utilize their location. That is, they have the shortest route among the network. Since wormhole attack creates false entries in the routing table. Detection of such wormhole attack is difficult and is a major challenge in the current scenario. Hence, we have attempted to detect such wormhole links in a wireless sensor network using a novel hybrid detection method, which we have named it as NRIS, or neighbor ratio isolation.
So coming to our proposed solution for the defined problem, we are using the hybrid method concept of using two concepts to detect the presence of wormhole. The first concept is the neighbor ratio threshold that we are using from a base paper. And in this, we generate a number of suspicious nodes from a complete network. So the proposed neighbor ratio threshold is to compare the neighbor numbers of the node with all its neighbors to give a list of suspicious nodes. And the second method that we are using is the isolation technique. Here in this, we select a pair from suspicious nodes, and then the selected pair is isolated from the network, and then network is initialized. The significant point of our hybrid mechanism is that we do not scan all the nodes. We just scan the selected suspicious nodes. The system architecture. In system architecture, we have logically divided our system in two phases. The first phase consists of stage one, in which we configure the nodes and initialize the network. In this, we check the performance matrix. That is, we check the wormhole characteristics in the network. If the characters are found, then we move to the phase two, or we can say stage two. And if characters are not found, then the program gets suspended there itself, justifying that there is no wormhole presence in the network. In stage two, we are implementing the NRT, that is the neighbor ratio threshold algorithm, where the shortlisting of suspicious nodes is the main target. The shortlisting is performed based on the threshold value that we are referring from our base paper. This list is generated by comparing the neighbor numbers of the suspicious nodes with all its neighbors. Then we move to our stage three of the system, where it consists of isolation technique to detect the target malicious nodes. And in stage three, we select a node pair and change its coordinates away from the network. And and then we check for the wormhole characteristics. If the characters are found, then a node pair is considered as the malicious link, and if the characters are not found, then the other pair is selected and the same process is carried out. So as we have seen in the architecture, the wormhole characteristics or the performance metric analysis is based on these parameters, that are the throughput, the packet delivery ratio, and end-to-end delay. If we analyze such trend as decrease in average throughput as well as the packet delivery ratio after the attack is implanted, and the significant increase in end-to-end delay, then we can come to a conclusion that there is a presence of wormhole in the network.
Yeah, so starting with the implementation, implementation begins from the implementation begins from us using the AODB routing protocol for generating our network. The packet variation goes from 5 packets to 50 packets with a step count of 5. Currently, we have changed it, which is different from this slide. The packet size is 1024 KB. We have kept it the same, and the data rate is 128 kbps for the packet transfer. The stage one of the process consists of the checking whether the overall network consists of wormhole or not. So what we do for this is we generate a data file which consists the initial and final performance parameter values of these performance metrics, which were discussed earlier. And then we combine all these initial and final parameters to generate a single file, which is network data.csv. And then if we analyze that file, and if a wormhole character is found in the overall network during the analysis, then we proceed to the stage 2. Otherwise, we proceed to the stage 1. Otherwise, we terminate the program there itself. And that is this facility provides a dual filter to the whole process. Coming to the stage 2, after we proceed from stage 1 to here, what happens is we shortlist certain nodes which are probable to be malicious using the concept of the neighbor ratio threshold. And when using this neighbor ratio threshold, we have kept the value of that threshold to be 1.1. The normal value ranges from 1.1 to 1.5, but according to our base paper, the lesser the value of the neighbor ratio threshold, the more nodes will be scanned, the more nodes will be shortlisted, so that no node gets skipped during the scanning process. Next, please. So after getting the suspicious node set from the stage 2, what we do in stage 3 is we generate the pairs from these pairs of these nodes using that suspicious set, and we isolate each pair at each traversal of the loop. We isolate each pair, change its coordinates to be away from the network, and analyze the remaining network. So what will happen is, if the isolated pair is actually malicious, then what will happen is the remaining network will be free from the wormhole characteristics. So that is, the wormhole character will disappear from the network. Whereas if the isolated pair is not malicious, the wormhole character will still be present in the overall network. So what you can see on the screen is the results after the stage 1 process. So this whole result set suggests that the overall network consists of a wormhole characteristic. Now, how are we telling this? Using the trends which we discussed earlier, the average throughput and the packet delivery ratio are decreasing, as you can see. Whereas after the launching of attack, the end-to-end delay is increasing manifold. So that is why we conclude that overall network exists in the network.
So, while we focus on the detection of a wormhole link, the potential also lies in the development of different methods to prevent the attack. Detection using this technique helps us to merge various other applications such as machine learning. We have implemented our project using 6 nodes by keeping in mind the concept of divide and rule. So increasing the number of nodes is also possible. At the end, what do we get? We have obtained the correct malicious node pair by analyzing the performance parameters of the overall network using the detection method proposed in the solution. One of the features of the process that we have designed is implementing the algorithm using minimal resources. That is, it does not require additional hardware. Now let's go through the demo in detail.
Hello, Tanmay. Your audio is breaking.
Oh yeah, is the screen visible?
No, not now.
Okay. Is it visible now?
No, not yet.
Please try resharing it.
Oh yeah, yeah.
Yeah, it's visible now.
Okay.
Continue.
Yeah, so
Continue
as you
with
can see
the
on the screen, the top right screen is the terminal which is collecting the initial parameters. That is, what we are doing is we are collecting the performance metric parameters, these values continuously, and we are collecting them at 2 different points of times. So the top right terminal is collecting the initial parameters, whereas the top left parameter terminal is taking into account the final parameters. what will happen after this stage is it is going to get combined in a single file, which is called as the network data.csv file. So as you can see, the whole thing is being carried out at each process, at each traversal. The first column which is there in the screen, it takes into account the number of packets sent at each traversal, and the corresponding three entries are the average packet average throughput, packet delivery ratio, and the average end-to-end delay corresponding for that number of packets. Yeah, so as you can see, the result file is generated, and after we execute the stage1.py file, which is that code which combines these two into a single file. So yeah, the result file is created now. Then can you please show that result file?
Oh yeah. So this is basically the data.csv file which is generated. In this file, we have integrated the two states where the attack is enabled and the other state where the attack is disabled. The packets are being sent from 5 to 50 with a step count of 5, and the parameters with their specific information is collected for every packet sent. So from this file, we basically generate the further results which we already seen in the presentation. So these are the general results which we have already seen in the presentation. In the basic, the throughput and the packet delivery ratio are basically decreased when the attack is enabled, and the end-to-end delays increased significantly. Okay. So we'll look at the let's look at the wormhole 3 file, which is basically the code which we have written for the implementation of wormhole attack. Tharwa, can you explain it?
The file is not visible on the screen yet. Yeah. So as you can see, the file, this is the first file which generates the overall network and also the routing tables from the network. This is the .cc file which runs on the NS3 platform, as you can see from the included header files of NS3. Can you please scroll down, Tanmay, where we generate the routing table?
Okay.
So this is the code wherein we just simulate the overall network, and below from where we get the routing table file. So this is the code which generates the wormhole.routes file, and hence after this we use this wormhole.routes file for generating the neighbors, for detecting the neighbors, as well as the whole neighbor ratio threshold detection process.
So the wormhole.route file basically checks for the hops which are present in the network and which are basically affected when the attack is enabled. Just a sec, I have to run again.
So basically, what we have done is we have kept in mind that the algorithm should use minimum number of resources. So as you can see, our algorithm does not use any external hardware, as well as some high performance computing setup is required. So that's what one of the features of our algorithm is.
So let's get to the last part where we have basically implemented our own algorithm. So this is the part which prints the whole graph function, and then coming to the check attack presence, Atharva, please explain.
Yeah, so as we said that the overall network is being scanned uh, for the presence of a wormhole attack. So as you can see, the function check attack presence is doing this. What we are doing is that we are averaging out the initial and final values of each of the parameters, and then we are checking whether the initial and final values are the trend for the wormhole attack is being followed for at least more than 50% of the times in the overall network. So what this means is when we send 5 to 50 packets with a step count of 5, there will be 10 entries in the routing table. So these 10 entries, out of these 10 entries, at least 5 entries should be such that the overall network follows the wormhole characteristics. Then we declare that the overall network consists of a wormhole attack, and then we proceed to the stage 2. So as you can see at line number 118, we're doing the same thing there. Average is greater than C by 2, where C is the total number of total entries in the table. And if this is greater than at least 50% of the times, then we return true and proceed to the stage 2.
And then we check for the alternate possible link, which is basically like when isolating a suspicious node pair. Once the node pair is isolated, we check for the possible link present in the remaining network, such that the data is basically being transferred from source to destination. If that is not possible, then we declare that an alternate link is not found and we cannot isolate the specific node pair. And then once we get a specific node pair set, we do the final check where the suspicious node set is determined from the initial node pairs, which is basically done by considering the other values, the difference, and all the comparison. Okay, just a sec.
You have 2 minutes to go.
Yeah. Just a second. Okay. Just a second. I can't.
Okay, your time is up. Are you still online?
Oh yeah.
Okay. We have a few questions.
Oh yeah.
You can stop sharing the screen.
Okay.
And you can also, both of you should mute now, and whoever is answering can unmute, and then after the answering is done, remute. Okay, thanks for the presentation. It was interesting. I was there in the last round, so I've seen this before. For the rest of us, I think we should clarify what is really going on here. So correct me if you're wrong, but if I'm wrong, but you're talking about an IoT security context wherein there is a kind of mesh network of IoT devices, and two of these devices are malicious, and they share a high-speed link between them. And the data, now the immediate impact of this is that the routing table before this wormhole, which is a high-speed link, whatever routing algorithm was there, it would get highly confused. But can you explain what exactly is the security problem here if there is a high-speed link between two devices and packets suddenly start appearing in another part of the network? Please unmute yourself before speaking.
Yeah, so as I yeah, correct me if I'm wrong, sir. I'm so sorry. As I understood what your question is, you are asking whether the whole packet system. Can you please repeat the question? I mean, I did not understand it.
So, what precisely is the security problem here if there is a wormhole in existence in a network?
Yeah, okay. So the major security problem lies here is that whenever an attacker comes in the, I mean, launches an attack in the overall sensor network, what happens is all the packets get transmitted through that tunnel itself, whether or not it is scheduled, it is supposed to be passing through that path or not. So what happens is the attacker is able to catch the packets and steal some information, or maybe alter the information which is going through that path, and it can lead to disastrous effects, which has already happened in some cases in Americas, also in some banking sectors. So that's what it can lead to disastrous effects, and the major problem is it is very difficult to detect because the whole tracking system, that is the routing table, is altered in this case.
Right. So, so basically, you are stating two different scenarios. One is that they steal the information. The other is that they modify the information. Now,
Yeah.
modification is much more difficult than stealing, but stealing does not require a wormhole at all. If you take a tap from one node and keep stealing the information without connecting to the other part of the network, you can still get most of the information passing through that node, right?
Actually, sir, what happens is in the case which you're stating, we cannot. I mean, the efficiency of that particular attack is much lesser than as compared to the what we get in a wormhole attack. So as you can see, most of the packets. I mean, if the attack without the wormhole is being launched, it can say I'll say out of 160 packets get transmitted through that path, but when we launch when we launch a wormhole attack, what happens is more than 90% of the times the packets get tunneled through that path through which the attacker is setting.
Right. So I think you have to clarify that that part. What happens is basically that because of this high-speed connection between two nodes, the routing table itself gets modified. Because of the fact that it is much faster. This particular branch is much faster. So the routing table, which is continuously updated, will say that, okay, let us route all the packets to this because it's so fast.
Yeah, correct.
So therefore, all the packets will start flowing through this tunnel, irrespective of whether it is really meant for these nodes or not.
Exactly.
That's what you're saying, right?
Yes.
Okay. I have one more question, but I'd like to ask my colleagues to answer their questions.
Yeah. So I was wondering, you did mention that there's some machine learning component that you can bring in, etc. Right? So what all have you done? What all have you thought through? Why would something like that be required? And second thing is, for analyzing the graph and all of it, right? What kind of packages I saw you using C++, and then I saw you using Python, etc. And you did walk us through the code, but maybe I missed out to what kind of tools have you been using, and what is that you've created novel, while putting together some of these codes.
Yeah, so as you have already seen, what we have done is we have the new thing which we have created is we have combined two different concepts of NRT. NRT is a concept which is already implemented from our base paper. That means we referred to that the base thing which we referred was that paper, and we took that concept of NRT and thought that instead of scanning for the whole network for the wormhole, we can use this NRT and combine with the performance metric analysis and create something new. So that's what we have done in this process. Regarding the code, we have used the NS3 platform. The NS3 files, NS3 source code is already there on the official website. We downloaded that code and just implemented those source files and generated a C++ code for simulation.
Right. Nilakandan, you have any question?
I know my question was exactly this one. What is the novelty in your approach? Okay, that's good.
Yes, so that's what we have combined two different algorithms to be new, and this algorithm proves to be, very simple to implement, as well as it is much faster than the existing algorithms.
Okay.
So did you with the new algorithm, did you also see some gaps, like, because you put this together, did you see there are some other issues that can pop up?
So there's one significant issue which I would like to, which is worth presenting here. That is the number of nodes which we have done. So at this stage, we have just taken into account 6 nodes of a network. So what we had what we had in our mind while preparing the whole project was, if the network consists of large number of nodes, then we'll divide the network into small groups of six nodes, and then we can apply this algorithm using some parallelization techniques, and this algorithm will work on these the groups of 6 nodes parallelly. But there is one thing, that we can increase this algorithm to work on a larger number of nodes.
What is magical about 6 in a network?
No, there's nothing magical about 6, but we have we tried doing it with 4 nodes, 5 nodes, 6 nodes also. What happens is the NS3 platform is a bit being an open source platform. What happens is the number of the simulation platform takes a longer number of time. So if you increase number of nodes, the compilation process takes a longer number of time for the whole project here to be represented. So if we take suppose 8 nodes rather than 6, it will take about 6 minutes or 7 minutes to get compiled to take the whole simulation process into running state.
Did you see 6 as mentioned in your base paper by any chance?
No. This whole thing is being done by ourselves only. This is not mentioned in the base paper.
6 is not mentioned, but otherwise,
No.
So in a graph theory, 6 has a very important context, and maybe it's worth exploring that.
Yeah, we'll surely do that.
Thanks. So last question. You just mentioned the computational complexity of the algorithm rises rapidly as the number of nodes increase, and you are proposing to partition the network and handle it separately. Now, as long as you are doing this not in real time, that is offline, that approach might work, from a historic perspective. So you analyze yesterday's results or whatever, then the time does not matter. But I see that there are other algorithms like these leash algorithms, which measure the geographical distance, which do not have this problem. So how does your algorithm compare with other algorithms in existence?
So what happens is when we use that geographic algorithm, the case might be that algorithm requires a larger, some kind of additional resources. What we have kept in our mind is we need to use minimum number of resources, let's say the CPU, or we don't require some other hardware for sensing the computational, the sensing the network routing. What regarding the what you said about the routing process, the the real time application, what happens is, even if we cannot apply this algorithm on a live routing, we can surely the whole if we are running a network, we are surely constantly analyzing the performance metrics, and we can surely continuously get updated, we can surely update the performance metrics required for this algorithm. And there might be two cases, one where you are in the network, you are a part of the network, and so in that case you will directly get those required routing tables also, and the performance metric data also. But if you are outside the network, then you need only two files, you need only two resources. The one is the performance data, the network data.csv file which we just showed you in that form, and the network routing table which we require for the neighbor discovery. So that the only two files are required for the whole execution process.
Right. I think we have to stop now because the time is up. But I also would advise you to consider the situation when the wormhole is random, meaning it switches off and on randomly. So your threshold is going to be affected by that process. That's something you might want to look at. So I'd like to thank you for the presentation of this interesting project, and we'll be in touch with you. You can now
thank you, sir.
Leave.
Yeah.
Okay.
Thank you so much. We also had a great time interacting with you.
Yeah.
Thank you, sir.
Thank you so much, team. Judges, now you can move to the discussion room. And we will have a short tea break and be right back at 11:30. Thank you.
Is anybody there?
Yeah.
I have not got the link for the discussion room.
Okay. I hope everyone is back. The CSI InApp National Student Project Award is an annual event that involves a 6-month process, starting from the call for application to several rounds of evaluation. This year, we had a little over 2,500 students from across the country, representing 96 colleges, with a total of 571 projects that were presented. Further to this competition, we feel it would be very useful and appropriate for a large number of enthusiastic students to gain insight from rich interaction with accomplished people from the industry as well as academia. Therefore, it would be our pleasure to announce a 3-day webinar series starting from July 2nd to July 4th. Topics like entrepreneurial, data science, biomedical engineering, and bionics will be discussed by eminent speakers. More on that later. Now, let us move on to the next project, which is crowd detection system by the team from Model Institute of Engineering and Technology, Jammu. Apurva, are you ready?
Yes, ma'am, I'm ready.
Okay,
Shall I start?
Just a second. Apu, you have 30 minutes, out of which 10 minutes are for the presentation and the rest for the demo as well as the Q&A session. Judges, can we start?
Yes, please.
Yes,
Okay,
Apu, you can start your presentation. All the best.
Ma'am, is the presentation visible?
Yeah, it's visible. You can start.
Okay, ma'am. Hello, everyone. I am Apurva Amla from Model Institute of Engineering and Technology, Jammu, and I'm here to present my project called Crowd Detection System. Let us first move to the problem definition. As you can see, with the rising crowd in countries like India, there are a number of problems in fairs, shrines, public places where there can be a difficulty in management of crowd. So, crowd detection algorithms are the purpose made for the use of management of crowd. Once the crowd is detected and managed, it will be easy for the government officials as well as the private officials for manage the crowd. So, these can be used for stampede detection, prediction, and early warning systems, as well as for ensuring social distancing, detecting curfew breaching, or even the analysis of crowd movement and deriving analytics for retail management. So the proposed solution is a people counting algorithm that we have built in the college itself using a real-time OpenCV and artificial intelligence. OpenCV is nothing but computer vision technology. Once the video camera feeds are analyzed by the system, they are passed in frames per second speed and the crowd intensity is built up through the system only. Once the crowd intensity is built up, the crowd analyzes it for density perspectives and then alerts wherever the crowd limits crosses a predefined threshold. The peak analytics, average analytics, and the low density analytics of the crowd built up system can be provided through the dashboard that we have specified along with the project. The collected approaches and the data can be used to facilitate the crowd management, and this then cause an efficient management of crowd in different spaces. The implementation of the project goes like the live video feed is analyzed using the computer vision, that is, the camera feed that is coming through a given camera located at a certain place. A neural model, in our case it is MobileNet SSD, has been trained upon local data using to recognize the human heads. Once the human heads or human forms are detected, they are continuously tracked one by one and collectively as well, using the optical flow algorithm in this case. The neural model then detects the density and compares the people count to a particular region number or region limit. The violation of predefined density limits, if occurred, results in an alert message as well as the SMS to the concerned security staff's mobile phone. We have provided the SMS to the concerned security staff because In case when the staff is not present for the surveillance system screen and he is gone to a particular venture on his own duty or in a field view, then the SMS will give the alert to the staff on their SMS mobile phone. The real-time crowd analytics are derived and displayed on the dashboard. Let us move to the technology stack that we have used in this project. For the software prospect, we have used Open Computer Vision version 4, deep learning model MobileNet SSD, that is single shot detector, because its accuracy is much better. The web platform includes HTML, CSS, JavaScript, and PHP codes. However, the database includes SQL 11.0 version. The platform that we have built our project on and tested is CentOS, that is the Linux terminal platform. And the hardware that we have used for the supplements of this system are UniView IP camera 2 megapixel, Dell Precision Workstation, that is processor Intel Xeon R, E2124 CPU with a clock speed of 3.30 GHz into 4 clock cycles, GPU of NVIDIA Quadro RTX 4000 PCLE. Let's move on to the workflow diagram. As you can see from the figure, the admin or the surveillance officer is sitting at the front end or a desk panel, surveilling a particular window. He has access to dashboard analytics as well as the motion density alerts that are coming to his mobile phones. Also, he can view the live feed, that is the surveillance screen. Once the camera detects a particular region of crowd and occurring cloud, the videos are processed in frames per second and are sent to the AI neural model of crowd detection. The crowd detection system core processes the video and then an alert is generated to the SMS as well as the display screen. Also, the data is collected and sent to the dashboard for analytics perspective. Let us move on to the demo of this project. We have created a environment of outside the shrine in our college itself and use the students as the passing passengers. Once the students are coming and coagulating at a particular place, they are being tracked and the system gives if they are moving or not. Also, you can see on the top left corner that there is a yellow circle right now. It means the density is an average limit. We have provided three limits of densities that are green, yellow, and red, and we can define all of them. Once the red is inserted, an alert is generated on the display screen, as well as an SMS is sent to the particular mobile or SMS that is registered within the security system. Let us move to the dashboard specifications of this project. As you can see, a log chart of people is displayed, which is in the dashboard itself, and I have screenshotted this portion. I will further show you the demo of dashboard as well. It can show you daily count, weekly count, as well as the monthly count of how many visitors are visiting a particular place or how much crowd was coagulated at a particular interval of the day. That is, we are having a peak hour analytics of the crowd. Let us move to the dashboard demo. This is the dashboard of crowd detection system that I have built. As you can see, there is a particular SMS box that will pop out and give you a description of the project. We have coagulated the project on different days and executed the workout time, how much time the project was used or coagulated for a particular region. A brief demo of the project is provided for the basic use purpose, and a calendar is also provided for recording the main events or peak hour analytics. Further, you can see that we have two tabs, UI display and operations. In operations, we have surveillance, where you can upload files that will be mainly the PNG, JPG or GIF files that are the images file. If you want to have the past analytics of a particular event. Also, you have the surveillance screen, which will show you the live analytics here. And then we have operations tag, in which we have analytics. Analytics will show you a live chart, that is the live surveillance of the feed, and the incurring crowds are prospected in the peaks of the chart. Also, the log chart of visitors that I showed you previously is displayed alongside the live chart. The live chart is the current feed analysis, while the log chart is the overall feed analysis of daily, weekly, and monthly visitors. So let us move on to the comparative analysis. The comparative analysis of the project is based on three aspects. That is, talking about the hardware one, it only has two of the possibilities that our system can track. That is, the operability and tracking through. The hardware and software are used for operations, while pressure switches are used for tracking purposes. However, in the software models, we have used the software for the operations, only the software, no cost of hardware will be included. And for the detection and tracking, we have used the person detection model. But for the landing AI workspace monitoring tool, there is no provision of SMS indication to authorities or PCAR analytics that we have included in our project. The future scope of this project is this, like increasing the efficiency and accuracy of system from 80 to 90% that we are currently achieving to 94% and beyond through local training in the local environment. Inculcating a social distancing algorithm by improvising the mean shift algorithm. Filing a patent under crowd detection behavior that we are on the way, and taking a project to business aspects through initiating a startup. We have already built in the startup cloud aspects with the MBA department of the institution only, and I am currently working with them in order to start a startup for this project. Initial interest regarding the deployment of this project has been received by the MITE Jammu through Sri Mata Vaishno Devi Shrine Board Jammu. I hope you like this project. Thank you.
Thank you very much for the presentation. It is an interesting project, and I'm sure the judges have a few questions for you. My first question is, when you have two cameras or multiple cameras, maybe 20 cameras,
Yes, sir.
how does your system cope with that?
Yes, sir. So we have not tested it with multiple cameras, but we are on the way to multiple cameras. But we have tested it with two cameras for the beginning of this perspective. What happens is, if we have situated cameras in different places, like one is in the east and other is in another block or department or region. So what happens is we have a surveillance split screen that just like a CCTV you can see it, and on what camera or which camera the crowd is going to be gathered, on that camera's perspective SMS will be popped out, like on this camera or the C3 block outside there is a crowd gathering. So for different cameras we have provided different messages alert.
Yeah, thanks for that. But my question is not monitoring two different areas. My question is about managing a large hall, like an airport arrival hall, where one camera is insufficient, and you need 10 cameras, like any typical airport arrival hall, or even a shrine. You have to have multiple cameras. You cannot manage as one camera.
Yes, sir.
So how do you manage that
So
situation?
in that case we are on the yes, sir. So in that case, we are on the way to manage a optical flow algorithm along with the mean shift algorithm that will coagulate the camera inspection and cross the intersection of the camera. Like if some of the people or IDs that are getting tracked by two cameras and they are similar, so the IDs will be popped out of the stack, and those ID won't be counted as crowd intensity in both the cameras. Only single camera will count those IDs.
Okay, I have one more question, but I will ask that after other judges have raised their questions. So the floor is open.
Okay, sir.
See, again, it's related. One question is related to what Satish was asking, right? But then, even within a camera, one of the problems with this kind of system is that within a camera, depending on how how many frames you're analyzing per second, etc., you should be avoiding double count, right? I'm not sure if I missed what you said. Did you say you used optical flow to ensure that the same person is not double counted?
Not
Is that?
getting tracked. Yes, sir.
Yeah, so that you did. Okay. Now you're using a camera which is 2 megapixel, and
Yes, sir.
how did it go well with your SSD model? So your SSD model it is heavy on computation, right? And
Yes, sir.
you said you used a 2 megapixel image. Did you have to rescale it so that you have enough frames per second? And what did you do? What is
So
a
basically, initially we started from ResNet
Mhm.
frameworks.
Mhm. And it was too
So
heavy.
it yes, sir, it was really heavy for the ResNet to handle such a big data set of
Okay.
the crowd or initial stacks. So what
Okay.
we have done in this project is we have built up the mobile net SSD on the head forms only. Basically, it is made for the human detection or recognition purposes, but we have laid off some data sets
Okay.
and we have built it only for the human head forms. So it makes easier for the computation.
Okay. So, as part of this application that you've developed, are you also measuring distance between people? I thought this is more of a social distancing app, so you should be able to measure distance between people, isn't it? Is that understanding of mine
Yes,
correct?
sir, we are able to yes, sir. We are able to measure a certain limit of distance, and we are hoping towards an future scoping the distances of large audiences. Like
Yeah.
we can measure the distance of 10 to 15 people. How are they going, and how much far are they standing? But
Yeah.
we are not able to measure much more. So we are currently proceeding towards that portion only, recognizing the current COVID situation going on.
Yeah, and we are talking about monocular cameras, isn't it? We're talking about monocular
Yes,
cameras.
sir.
Yeah. So now, how did
Yes,
you
sir.
take care of the distance aspect, right? So one is the perspective aspect, right? Because your camera, scenes that are far away from your camera is smaller, scenes that are closer are larger, right? And then you have this perspective problem, right? How did you take care of that?
Yes,
And
sir.
all of what
So
you said about landing.ai, they have all of that in their website, right? So
yes,
how
sir.
did you handle it in your application?
So basically, we have used the bird's eye perspective, like a bird sees or views a particular phase of, like region. So
Yeah,
the
but
camera also is particularly placed at a certain distance. So it is required for the camera to be placed at a certain height from where the region will be perspected.
yeah, so
Only
now
then it will work.
the problem is that bird's eye view is only possible if you do certain kind of transformation. It's called perspective transformation,
Yes,
right?
sir.
What did you use that, or as of now it's still in early stage, etc. And if for that, how did you manage that? How did you even get the value? If you used perspective transform, how did you gather the value for doing that transformation? How did you calibrate the camera?
So what we did is we measured a particular perspective of the region from where the camera was situated,
Uh-huh.
right? So we have created a particular pixel area for which the camera is bounded to be having the region location.
Mhm.
Like inside the camera frame, we have defined another frame for
Mhm.
which the camera will judge the people if they are coming in, getting tracked or not. So only for that much particular frame inside the
Right.
camera, the
That
people
is,
will be
you
tracked.
have a single line, or you have a small rectangle through which
Yes, sir. Rectangle
you,
like thing.
so
Yes, sir.
more than that, for the distance aspect and all of it, you need to do that. So for you to get to the bird's eye view, right, you need perspective transformation, right? Did
Yes,
you
sir.
look at that perspective transformation at all? Like, even if it was
So
out of the
we are
box?
currently researching upon that topic and we have manipulated a bit of the code for the bird's eye perspective.
Okay.
So we have certain problems that we are facing, like the bird's eye perspective view is not compatible with the version of the project that we are currently working. So we
Okay.
are evolving the project towards that perspective so we can achieve better outcomes like accuracy I mentioned. So we are going towards that stage.
Okay. And you mentioned two cameras being used. Were they of the same configuration?
Yes, sir.
If it
Yes,
was
sir.
different configurations,
So they
what
were both the UniView IP cameras.
Yeah. Now let us say when you're rolling this, you said you wanted to do a startup, right? And when you're rolling
Yes,
it
sir.
out as an application, right, you're going to have clients with all sorts of cameras, right? How do
Yes, sir.
you want to, calibrate? What is the kind of, is there a scaling factor that you should be using, etc.? You
Right. There is a scaling factor of like we cannot do it for thousands and thousands of people, like 2,000, 3,000, and more. But we have considered it for departments, retail works,
no,
where
no,
the customer limit is less than.
no, we're not talking about you're talking about in a computer vision context, in a camera context, specifically in an application like what you're working on, there is some term called scaling factor, right?
Yes, sir.
And has anything like that been utilized? So
So we have scaled the
from
network enough to be used for multiple cameras. Like we can scale up to 4 to 5 cameras for now, and we are going to achieve a bit further for by using some help of programmers and high-end
no,
professionals
no,
for
no,
this
this is not
project
that scaling we're
that
talking.
our institute only is provided.
This is not this, that we're not talking about the scalability, right? In a computer vision context, when you're talking about cameras and perspective transformation, there is something called a scaling factor, right? And which is to do with your pixel size and how does it translate to real length, etc. And so I'm not
Yes,
talking
sir.
about scalability of the application. That's a different topic. We're talking about computer vision. Your problem is a computer vision problem, isn't it? So have you
So,
thought
but
of
yes, sir, we have thought of it, and the scaling factor that you are talking, like in the perspective of camera pixels and accuracy of camera, how will it achieve that? In that sense, our camera has nothing to do with a lot of precision and accuracy. Like we don't need a high-end camera or 4 to 8 megapixel cameras. We can achieve this from a 2 megapixel camera
yeah?
because the
I think you're getting my question wrong. I think I will. So the point is, it's not about scalability at all. We're not talking about it's a technical term of computer vision. Um, when you have different cameras with different pixel sizes and different resolutions, right? There is some adjustment you do, and that's called scaling. It's worth exploring that because for an application like this is very important, right? If you go to landing.ai
yes, sir.
or any of them, they also mention for every camera there is a scaling factor that they have to calculate, and that's like the magic number in this whole application, right? You are supposed to find out that scaling
Yes,
factor,
sir.
and that is usually kept people don't talk about it clearly, right? In any open source application that is in this line, if you when you go to reach very high accuracy like 95, 98 kind of
Yes, sir.
accuracy, then or 80% plus, right? Then the scaling factor becomes an important thing. It's worth going and exploring that. And this is we're
Okay,
not
sir.
talking about scaling the application. We're not talking about scaling in terms of number of cameras. We're talking about purely image processing, data that is coming from camera and analyzing that. It's worth looking at it. It's very good at thing that you've done.
Okay, sir.
Maybe take some of this as an input and go and research and make your application better.
Okay, sir. Sure.
Fantastic.
Yes, sir.
Thanks for that. Nilakandan, do you have any questions?
No, I don't have. Okay.
So thanks. I have one last question. This is in fact, what the previous question was referring to was that cameras are different. Some of
Yes,
them
sir.
are high resolution, they have higher pixels. Some of them are cheaper, they're smaller,
Lower pixel.
lower pixels, and so on. So now, how do you standardize this? And that is a factor that is used across these different types of cameras. Now, my question is also somewhat aligned to this, but it is on a slightly different topic of how you have parameterized the crowd density. Now, suppose you have a room in which you have put 2 or 5 or whatever cameras, and the owner of the application says, "I want 2 meter separation from between every two persons in this room." So you have built an application that does exactly that. You have put multiple cameras in multiple places, and it will detect if any two people in the room is closer than 2 meters. Now,
Yes, sir.
the owner says, "I want this 2 meter reduced to 1 meter." Now, which part of your program will change?
So we are in the perspectives of this, like social distancing of the thing. So we have defined a particular disappearance index, that is a person disappeared from a particular place with respect to the other personal. That is the ID is tracked and the ID is disappearing from a particular place, and the other ID is situating at a particular index.
No, no, we're not
So the
talking about.
distance
Suppose there's only one camera in the room.
yes,
Okay,
sir.
there's only one camera now. Forget about the two cameras, that makes it more complex. There's one camera in the room, and your system is now working fine with 2 meter separation between people. If somebody comes closer than 2 meters, you will have an alert. It's working fine.
Yes, sir.
Now the owner says reduce this 2 meters to 1 meter. My question is, which part of your program is going to change?
So we have defined a max disappeared index list that induces the indexes that or the IDs that are getting tracked, and they are in the particular range of 2 meter or less than 2 meter.
Okay,
So we
that
can
means,
change that distance.
The earlier question about parallax is now an issue. Suppose you're talking about disappearance factor. If one person is completely covered by
Yes,
another
sir.
person, then how does your system figure out the difference between them? There are two people standing in a row and the camera is in front. You can only
So
see the first
basically,
person.
yes, sir. I get your question. Yes, I get your question. So basically, occlusions are a really common problem in computer vision perspective, because the system is not that much intelligent like humans. If a person is standing beyond a person, it will not detect that person. But once that person moves out again, it will get detected again. So it will be counted again. But there is no provision that we can do for occlusions.
Right. Okay. So I think thanks for your presentation. It is a very interesting topic. Are there any other last questions from any of the judges?
Satish, I just wanted to give her a tip.
Yeah, go ahead.
So what you could do is occlusion is a problem, but if
Yes,
you
sir.
see only one frame at a time, right? But if you saw
Yes,
it as
sir.
a sequence, it's not a problem like humans would do, right? It's worth maybe bringing in
Yes,
sequence
sir.
models, and that will help you. So going beyond CNN or a CNN-based,
Yes, sir.
you maybe want to look at sequence of frames, right? So look at sequence models as well.
Okay,
Combination
sir.
of this would actually help. Yeah.
And I
Thank you,
thought there's
sir.
also this whole stereographic vision, which might help also. You know, two cameras which are looking like two eyes,
Yes, sir.
etc. Okay, so thanks very much for your presentation and best of luck. And we will get back to you with the next steps. Thank you.
Thank you, sir.
Thank you, Apurva. You can leave now. Judges can move to the discussion room, and the next presentation will start at 12 p.m.
Hello, is everybody in from your team?
No, ma'am. One person is remaining. He'll be joining.
Okay. Okay, before you start, I'll give you some introductions regarding the time management. You have 10 minutes for presentation and remaining 20 minutes is for the demo and the question answer session by the judges. And if you have any problem with the connectivity, please turn off your video. And only the person who is presenting and speaking needs to unmute themselves. All the rest, please stay in mute.
Okay, ma'am.
Judges, can we start?
Yes, please.
Yeah. Now, we have a team from Vidyavardhini College of Engineering and Technology, Mumbai, Maharashtra, to present their project on the topic, an augmented 3D tourist guide. Go ahead, team. All the best.
Hello, am I audible?
Yep.
So just give me a second. There seems to be an issue. Okay. Yeah. Okay. So good afternoon, one and all present over here. This is our team from Vidyavardhini College of Engineering and Technology with our project, an augmented 3D tourist guide. So first getting into the problem definition and why we are doing this project. So over the world, over the globe, there are various tourist attraction and destinations wherein tourists visit, but many of them are not in a very good condition. And also there is an issue that proper knowledge or proper information about that place is not circulated. So we are here to solve that problem. And also it is possible that not providing proper services to the tourists can lead into a degrading of that particular location in general, that the persona of that particular place is not good. So we are here to tackle that problem. And these are the various kind of structures and monuments that we are looking forward to build up as such. And you can see that many of these places are physically deteriorated, which could be because of the climate changes over there or human interaction, any of which could be the case. What we are doing here is we are using our application, which is an augmented reality based application, which virtually completes these structures. And by that, what I mean, we'll get to it in the later slides. So giving you the overview of the project of as of what we are doing and how we are doing. So here I can see like we are tackling the issue of monuments and heritage sites which are not in a really good condition right now. And also it is possible that information is not available in proper order, proper sense, or verified information for that matter. So we are taking care of that. So to do that, we have created an application and a web portal. Application is something the user himself will be having which he can use to, complete these structures. We'll get to the demo as well, and web portal, wherein we can see the analysis and validate the information given by the user, and just make the functioning easier for the end user. So why exactly are we getting in this particular project? So here are a few statistics that we went through and we saw a potential here to develop. So here in front of you is the inbound tourism in India. These are for the years 2015, 16, and 17. The numbers are rather rising in a linear scale, but you will be astonished to see the foreign exchange that we are getting from it. Here, it is clearly visible that the foreign exchange we are getting because of tourism is increasing exponentially. And we see that there is a market to be tackled over here, and we see that we have growth in this particular region. These statistics in front of you are the GDP contribution of tourism to India. And as you can see, in the year 2020, it is estimated to reach an all-time high of 30 billion Indian rupees. But we see that this particular number can be grown up in a very large scale. So the entire package or the entire system that we are presenting you here is divided into three parts. That is the CMS, which is for the admin purposes in the back. The backend is for the data processing, and the mobile application, which will be used by the user himself. Just going through the various technologies that we are being using in this particular project. Okay, so this is the use case diagram. As you can see, there are 6 entities which intertwine with each other for a very flawless movement. The user interacts with the application, and the application itself has these various components down there. So these components are intertwined in such a manner that the user does not face any difficulties while using the application, as well as it is hassle-free for him. So getting into the UI of our application over here, first of all, it is a mobile application, and hence we have a login screen. But here in login screen, as you can see, there is both option for login and sign up. And if you do not have credentials present as such, you can sign up. For signing up, you can use either Google or Facebook account, which is enabled. Then we have the dashboard. If you have the credentials, you can just put in the credentials, hit login. You are introduced to the dashboard over here. Now this dashboard is basically divided into 3 parts. And the second and third part is where latest news section and new offers. So by latest news section is if you are in a particular geographical location, we can show you relevant information about that place as in general. And for new offers is, for example, you are currently in Pune, for example. So our application will prompt you that these are the places nearby, and you can visit these places that we'll be giving into the new offers over here, and you can buy the packages for those places. Meaning, if you are going to an X place, you can buy the package of that X place. This we have done to tackle the problem of internet connectivity not being available at those locations. So we are tackling that over here, and hence we can use our particular platform in offline manner too. So once you hit the click here to open camera, so a camera will be opened obviously. This camera, when pointing to structures and monuments which are broken and are being completed by the our project, will be displayed. What we mean, we'll get into the demo part as well. At the top left corner, we have a media play button. So at any particular location or at a structure or a monument, if an historically important incident took place over there and we have graphics available, relevant graphics available for that place, can be played by using that media button. This button will be enabled only if we have graphics inbuilt for it. Under that, we have the offline map button. So as we said, there is a possibility that you may not get network at remote places. So to tackle that, we have this offline map, clicking on which you will be shown a static map of where you are and what other structures we have completed. Just in case if you have internet connection over there, you can hit the navigate button up top, and the Google Maps will be open for you. So demo will be continued by my friend Sanchit over here.
So now for the demo part. Currently, you are seeing my mobile mirroring on my computer laptop. So first of all, I want to tell like few of the structures we have taken the printout. These are the structures from the Vasai fort. So here in the structures, you can see that they are been physically deteriorated, and there is no as such means extra information made available to us by just looking at the structures. So now if I switch to my mobile application, so here you can see that the deteriorated part of the structure is been getting is been getting completed by augmented reality through our application. So now if I zoom in and I zoom out, then to the augmentation is not breaking. Even though the harsh angles are being taken from the mobile camera, then to the augmentation is holding pretty well. It is automatically getting scaled in and scaled out. Therefore, we have worked on it to make as much realistic as possible. So in this manner, you can see like even through taking the maximum closeness, or if you move out, then to the augmented reality is not breaking on this part. Now coming to the second structure, here you can see that the upper broken wall is been getting completed, but in this structure has some historical significance event that took place. So by that what I mean is, if you see this structure, if I place over here, this structure is getting completed, but here you can see that this up on the upper left corner, this play button is been disabled because this structure we don't have any relevant graphics, but for this structure this play button is getting enabled. So if the user wants to have a visual representation of the incident that happened at this structure, then they can do that by simply pressing on that button. So if I press on this button, so you can see just in front of that we are getting a video played. So this feature has been called a story mode. So if any historical event has taken place at that area and we have relevant graphics for it, it can be played over that screen. And the best feature is, for playing this video graphics, you have to point your camera toward that structure. As soon as the structure is moved out of the focus, the video will be stopped playing. So this is one of the story mode feature that we have introduced in our application. Second is the offline map feature, which you can see over here. All the structures that are been completed by us is been highlighted into the star marks, and the structure that you are near at, you will be prompted with that. Next structure I want to show is this structure. So first let me switch it from normal camera. So here you can see that there is just a normal wall, but in the actual scenario when we went to research over there, so there were actually a darbar present over here which was entirely deteriorated and degraded from the ground. So if we move to our application, it will complete the entire darbar that is in front of it, like all the pillars and everything is been completed through our application. Now here I want to show like this structure is a special structure and we have done something extra for this structure. So this we will be demonstrating through our live implementation that we have taken through our application. That will be continued by Aditya Manse.
So continuing from where my friend left, as you can see, these are the structures that he showed, and these are the structures in real life that we went and saw. To the left, we can see how the structure looks right now in real life, and to the right, what you can see is the completion of the structure using our application. You can see we are subjecting the structures to harsh angles, but still it is not breaking. So this is the next structure that we talked about, and which had the historical importance, and hence we have implemented a graphic for it over here. So it is completing and getting to the so story mode of the structure. So now that this particular location has a graphic for it, You can see at the top left corner, the media button is enabled. Once hitting that, this particular video is played. Here it is just for the demonstration purposes that if you have a graphic that can be played. And again, coming to the offline map thing that we told you. So top left corner, we can see the map button. Once hitting that button, you will be taken to the offline maps that we have. This is obviously can be hit from any location that you are after pointing the location. The application knows that you are at this particular location and it will show you where you are exactly. Hitting the navigate button will take you to the Google Maps. This is the live location that it shows. And after this, I would like to show the pillar reconstruction that Sanchit just talked about. So what special have we done for this particular piece over here? So as you can see, over here, you in this frame, you can see the color gradient of the patch that we have applied over the actual image is very similar to its background. So we have implemented something called as depth sensing analysis. So what it does is it picks up the background color, what it is right now, and it superimposes over the patch. The main reason to do this is that tourists can visit a location at any point of day. So it could be morning, evening, afternoon. Depending on at what time the tourists go to the location, it is possible that the lighting is very much different. So to tackle that problem, we have implemented this feature. So also this particular thing, gives good user experience, and which is important for any application, I feel. And because of implementation of depth sensing analysis, the augmentation looks very lifelike. So that gives a good feedback to the user himself. Yeah, so this is what I was talking about. It looks like a part of the structure itself. It doesn't look like the augmentation that has been placed over it. From here on, Sanchit will get back to you.
So from here onwards, let's talk about some of the terminologies after seeing the presentation. So first terminology is virtual reality. Virtual reality lets you tap into a whole other reality or the dimension, you can say. But we are using augmented reality. In augmented reality, you can realize the virtual objects can interact with the real world environment, and thus it can provide a seamless experience. So second, here are some of the algorithms that we have used in our project, which will be discussed further. But here I want to target about the photogrammetry method. So the photogrammetry method is being used to transform the 2D images into the 3D images. So what is tell us, like, if you have a structure, you can take multiple snapshots of it. By taking the multiple snapshots, then you can provide it to the softwares like Blender and Maya, and from that 2D images, a 3D cloud mesh will be prepared. So here you can see on the left, a 3D cloud mesh is been regenerated from the 2D images, and this 3D cloud mesh then can be used to complete the broken parts and for the identification of the structures. This technique has been majorly used in virtual history and virtual museums. Museum of Britain is a best example to give for virtual museum. Here we are using augmented reality in mobile, therefore it is called as mobile augmented reality. So now coming into the algorithms part. First is the SLAM algorithm, which are used to identify the feature points or the key points for a particular structure. So what I mean by feature points and key points is like, here you can see for an image, all the plus signs that are being shown is been identified as the feature points, which can be used to uniquely identify a structure. So these are the outputs of the algorithm that we have shown over here. So for starting with the SLAM, SLAM was the initial algorithm that we were using to identify the feature points and the key points of an image. Later we switched to Fusion algorithm because this is the upgraded version of the SLAM algorithm. These are the following benefits of the Fusion algorithm. And on the right side, you can see that the accuracy of the algorithm depends upon the dimension of the image that you provide. The rich the details in the image, the higher the accuracy it will produce. Now coming to the depth sensing part, we have used depth sensing algorithm for this. So in depth sensing, there are two types that from when it can be achieved. First is single frame depth sensing and another one is the multi-frame depth sensing. Both comparisons are being shown over here. For depth sensing, we have used a triangulation formula. This formula is used to map.
Have 3 minutes more.
This formula has been used to map the 2D points into the 3D environment. Now coming to the architecture part, so how this all is been working. So if you point a camera toward the structure, that structure will be detected and sent to the central repository. In the central repository, it will find the appropriate match for that image. Now, for matching it to the completed model, it will first get the feature points of that image and it will try to match with the feature points of the other image that are present in the database. Obviously, the feature point will be looking like this as we discussed earlier. So here, if you can see the mapping, so most of the mapping are out of phase. So it will take another image, extract its feature points again, and now it will try to get it mapped. So here you can see that the mapping is been properly done and it is greater than the threshold. So it will identify like this is the structure that it has to use to complete the input image. Now it will run an edge detection algorithm on the input image and that information will be propagated to the completed model. From the completed model, then we get to know what are the broken parts that are to be completed. On this broken part, we perform the depth analysis and this depth analysis will regain its original color. Now this result will be sent to the central repository and the central repository will send it to the mobile camera. So in one sentence, if I want to complete my architecture, then on the final result, you will get your structure completed on the mobile in this fashion. Now the output that we were able to produce is the first structure that you saw. On the left, it was currently like this, and from a mobile application, we were able to produce this result. Similar for this image and similar for this image as well. These are all the references that we took to complete our project. Thank you everyone for patiently listening to us.
Thank you very much for this very interesting presentation. We would have a few questions. My first question is, how much of code have you written for this, and can you show us your code?
Okay.
So just to add to Satish's point, right? You claimed to be talking about SLAM, and I think there was also some inaccuracies. SLAM is not used for extracting key points and descriptors. You might use a SLAM. You might implement SLAM using key points and descriptors, but it's not used for extracting it, right? So that is one. And second thing is all of what you've said are extremely complicated algorithms, right? And if you did it, I should congratulate you that it's worth going on to start your own company, right? Any company which was doing R&D in SLAM, after a point in time, you would see that if they were working on open source projects, after some time they would stop doing that and then they would go and raise $1 million fund. So, but so the point is, did you work on SLAM, right? And or did you just use Vuforia?
Okay, we have used Vuforia. So if you move
So
over here.
maybe would you answer Satish's question, and my question is like something that would add more meaning to while you're walking us through the details, right? We will start seeing things.
Okay, so first, I'd like to answer your question. We have used Vuforia engine and Vuforia database. So the algorithms that we have used was not actually the SLAM because Vuforia engine uses a mixture of SLAM and VI SLAM that resulted into the fusion algorithm. So Vuforia engine is been using the fusion algorithm to identify the key points of the images. And secondly, for the coding part, So we have used Unity 3D for our application.
Yeah.
So this is the default initialization, and this is the event tracker that we have used. So here you can see like all the codes, some are been provided by the inbuilt Vuforia engine, and other that we have added. Like you can see if the trackable events are be found that are being handled by all of us. For the broken map sections, like all the coordinates that we have taken place is been identified through this. Then playing the video script.
Can you show us some code that you have written
Yes,
as
these are
opposed to
the,
the standard code?
yeah, these are the codes that we have written.
Yeah, just hold it there. Let's just take a look.
Okay. Yeah.
So what does this part of the code do?
So this part of the code is being used to uniquely identify your position. Like if you point a camera toward the structure, if that structure has been identified, then that map has to be shown over there, right?
Mhm.
So this structure, like if the trackable event is being named as this, then this map has to be shown to the user.
So what are the lat long hard coded numbers?
Because here for the presentation point of view, we can't go to the actual location, right? So for the demonstration point of view, we have to put a lat long so that it can open the Google Maps. But if you went to the actual location, like we saw, like we show you in the video, there the Google
No,
Maps
don't
is,
go back to the video. You hold it there in the code.
yeah. For the presentation purposes, we have to do it like to navigate to the Google Maps. Like this application is work only in the 3D environment. So like I showed you in my mobile also over here, we have to specially configure it to get that mobile view because it doesn't work on the 2D objects. Otherwise, you would sit at your home and just point your camera toward the structures.
So at this point, you are assigning some on line number 65. You are inverting a particular variable, and then you are assigning a name, map name, then send to Google Map dot coordinates. You're assigning another number. So
Yes.
what are you doing with this variables? This is only assignment here.
Yeah, so first this variable is being used to disable the play button.
No, that's okay.
That,
I'm asking about other two assignments.
okay, so
The
this
show
this
map and send to Google.
yes, so show map is like we have shown you the offline maps that we have provided. So this is the location of the offline maps that we have used. Upper wall map is the name of the image that
No,
are
no.
being
Can you
used.
take us to the point where these variables are being used? You are initializing them here.
Okay.
Where are they
Yes.
getting used?
They are used over here.
Yeah, what's happening? What is the action that has been done with that? So I
So
see that
if you are,
that sprite is again the same thing has come back here, or that variable.
yes, yeah, in the else you can see like this part has been getting executed. That variable has been set over there, and this variable here has been initialized once you click on the show map
But
button.
I don't see that Google variable here.
Because that has been passed in the navigate button. Mm. So if you click to get over here, there you can see that the coordinates have been passed over here.
That was not the variable name.
That is, wait.
Okay, in the interest of time, I'll pass it on to my other colleagues
This is the,
for
like you can see the name
questions.
is sent to Google Map and dot coordinates, and here you can see the file name is sent to Google Maps, and this is the coordinates. The file name, and this is the variable name.
Okay, so I will pass it on to my colleagues for more questions.
Hey, see, again, SLAM was used entirely with Vuforia. Is that correct?
Yeah, Vuforia is using fusion algorithm, not the SLAM. Currently, it is using fusion algorithm.
So you just put that more for discussing. Anyway, so
Yes, we have to
when
provide.
you had a lot of slides with key points marked there, right?
Yes.
And did you put that to use, or if you put that to use, what did you use for extracting that? Is there some open source package you used, or?
Yes, we have the Fusion Vuforia Vuforia website itself. Euphoria website allows us to extract that feature points to us.
Oh, okay. So there are algorithms like SIFT, ORB, brief, fast, right? These are the algorithms that are used for extracting key points and descriptors, or something which might be proprietary, right? These are the common ones. And I think what you used is an application, but you really didn't know what exactly is happening, and that's good. That's okay as well, right? So you just used a third party uh, SDK. So our point is, what is novel? If that is the case, right, you used an SDK. It is okay to use an SDK, but what is very novel about this AR app, right? Do you understand what I'm saying?
Yes. So
Beyond
first,
an ordinary app where you have maps and you have used Vuforia, what is that novel thing about this application? And I'm not saying you need to get into the details of a SIFT, SLAM, or by any of those kind of things. It is perfectly okay. Right? You could go on to use third-party SDKs, but there should have been something really awesome about this app, right? Something very innovative, right? What is that innovative aspect? Can
so
you just?
yeah, so first of all, the reason for using is the Euphoria itself because it gets integrated with Unity 3D application very well, and it has been widely used all over the world for the augmented reality. And from the uniqueness part that you are saying about that we have been implementing is first we were able to uniquely identify the structures that are present in the real world environment, and on the basis of that we were able to complete that structure through a mobile application as well as show information about that structure. So whenever if you went to a place, if I show you, if you go to a fort, you will be seeing the degraded part of that structure. But now if I say it, if I go to your fort, you will be able to know more about it. You can see graphics related to that fort, and you can see that the broken part of the fort is also getting completed in the real time. So it didn't just excite you much to go to that location and try it by yourself?
Yeah, see, it would be definitely novel if there was auto completion of. There are applications, even Photoshop actually auto completes now because of deep learning and a lot of AI components there, right? So when you said your mobile app actually auto completes the picture, right? What
Hmm.
exactly was done? Because I heard you say, "Hey, we are going to do depth analysis." So I think when you meant we are going to do depth analysis, you wanted to say that there was 3D, based on some mechanism, you completed the 2D image and then you overlaid the depth aspect to it, right? And is
Yes.
that so? The point is, how did you complete that? How did you complete the 2D one? And
Okay. Okay.
second is,
Okay, so first of all, the first part I would like to answer about the information that we have used to complete the structure. So let me tell you about the process. So for completing the 2D image to 3D image, we have used photogrammetry method. Now, photogrammetry method requires a huge amount of images, like 500 or 1,000 images. So
yes,
what we have
you
taken, like,
stitch together all the 3D, and then all of us in the panel actually know photogrammetry very well. So
okay,
we've created the 3D. So you took a mobile phone or a camera or something.
yes, and we took a video out of it and we extracted the multiple frames from it.
Yeah, you stitch them into a 3D object, right?
Yes.
But how is the autocomplete happening there?
So after this 3D object has been completed, we have to manually complete that broken part of the images.
That is my point.
Yeah.
That's a point, right? So if it was an
Because
automatic, if it was an automatic thing, it is very novel. This is real work, right? It's not
so
cheap.
we have discussed with the official that were present at the structure. Like autocomplete part we have tried, but it was giving arbitrary result. Means it
That's
was
true.
not showing the structure as it was present in the past. So like don't want to temper with the human emotions or with the importance of the structure. So what we have planned over here, like if for completing a structure, like we have to do it manually. So we went through the manuscripts that are available on the Google. Suppose if an image has been broken like past 50 to 60 years, then it image has been present on the Google Maps. But
Okay.
suppose Vasai Fort was broken 500 years ago. So
Yeah.
we went to the official, get the information through them, like how the structure will be. And then we have completed that structure. And
Okay.
after completing that structure, we have future plans to get it verified from the Archaeological Survey of India. Once they verify like these are the proper states in which the structure were present, then we can roll it out in the public.
Fantastic. So I think it's a very nice idea for sure, but somehow we are seeing the level of very high-end technology or innovation in the technology side is, at least that's my opinion, right? It's a little limited, right? But I think it's worth exploring this further. You guys are doing great. Um, Keep it going. I think AR is going to pick up well in the coming years, right? Although it's everybody's talking about it, nobody's actually using it as much, right? But in the coming years, this all is going to become a big thing. Keep going, and nice work. Thanks.
Thanks for that. Nilakanta, do you have any questions?
I just one simple question. You mentioned about after the analysis, after coming out with the real augmented picture, you are putting it in the repository. So likewise, is there a if the specific location is also already in the repository, will it give a quicker result?
Sorry, can you repeat your question?
Okay. In one of the video, you said that okay, you take a picture from you through your mobile.
Yeah.
Then it is passed to the repository.
So actually, we don't take a picture. It is in the real time. Like if you point your camera, that image
Okay.
will be automatically sent.
Okay. Okay. So and after the processing, after the processing, and you get a augmented picture, and that is again that is stored to the repository. So I understand it. Say the reason for going to the repository again is to uh, uh, save it there, store it there, and okay,
Yes.
if somebody is taking a picture second time, okay, another time, if the augmented picture is already there, will it automatically pop up there?
It will not, because the camera position has been automatically changing every time, right? So depending on the camera position, it has to complete that part.
So
So
okay, there is okay.
to avoid that continuous hit, we have provided this bundle thing. Like if you download a package of a, like suppose there is Vasai Fort, if you download that package, then your mobile application will be totally offline. There is no need to go to the repository to fetch the image again and again.
Okay.
Okay.
So
Yeah.
I think because of time, I think we have to stop the discussions
Yeah.
here. So thanks very much for your presentation, and we will get back to you with the next steps.
Okay. Thank you, everyone. Thank you for patiently listening to us.
Thank you so much.
Thank you, team. Now you can leave. Judges can move on to the discussion room, and the next presentation will be at 12:45 p.m. Hello, Jacob.
Yes.
Is everyone ready?
And they are coming. Two more members.
Can you please ask them to join soon?
Yes. Yes. Actually, okay.
One more left to join, right?
Yes, he is currently joining.
Okay, let her join. I'll tell you the rules. We have 10 minutes for presentation, 10 minutes for the demo, and 10 minutes for the question and answer session.
Okay.
And make sure you keep to the time. Yeah. Is she facing any problem right now?
Let me call him.
I'm currently calling him. I think he's facing some difficulty in entering. We'll give a. Yes, he's coming right now. Hello.
I'm sorry for the delay.
Okay. Next, we have the team from Sri Chitra Tirunal College of Engineering, Trivandrum, Kerala, to present their project on the topic Natural Language Interface to Database with Data Retrieval. Go ahead, team. You can start presenting.
Good morning, everyone, and good morning to the judges and also to everyone on the live stream. So just give me a minute until I share my screen. All right. Okay. So, all right. So we are a team from Sri Chitra Tirunal College of Engineering, and we are the team members are Gayatri Krishna, Jacob James, and myself, Praveen G. Anand. And we're going to be presenting on the project Natural Language Interface to Database with Data Retrieval. Now let's get into it. We'll do a quick recap of what we did in the first evaluation and also through the video that we sent in. So let's get into the problem statement. Now the problem statement defines what is the current problem, why is it a problem, and what are the solutions that exist to the said problem. So let's take a look at what the problem is. So as of right now, every organization has its own specific database where it stores data regarding its employees, its clients, its services and products, and so on and so forth. And the problem is that if a technical or if a non-technical person or a personnel within that organization wants to access this database, they cannot access this directly. They have to either use an organizational specific interface if it exists in the first place, or they will have to go through the IT stuff, or they will have to learn SQL themselves to access the database. But let's be honest, this is not feasible. And this involves, and this poses a problem in case of time-sensitive applications, as would be seen in healthcare, and time-intensive applications, as would be seen in, let's say, warehousing, which will take a lot of time. Now, what is the proposed solution, or how are we planning to tackle this said problem? So what we're planning to do is we are about to take a natural language in English, which is very unstructured and vague, and we are converting that into the corresponding SQL or structured query language from this said natural language. We will be searching this SQL into the database and retrieving the data and presenting it to the user in a formatted way so that they can view it. Now, this is a quick recap of what the problem statement is and what the solution is. If the user wants to access a database, they either have to go through an organizational database if it exists, which poses a learning curve, a bit of a learning curve. And if they have to go through the IT stuff, there will be administrative overhead. And we are planning to eliminate having to learn SQL, having to go through the learning curve of using an organizational specific database, or having to go through the administrative overhead of going through the IT stuff. So now let's take a look at the use cases of our project. That is, first of all, we are planning to put this forward to auditors. Now, auditors can directly use this interface to interact with the organization which they're auditing, thereby cutting down the time of time and having to rely on the technical person of that company to go through to that company's database, thereby bringing in a level of credibility and reliability. And even in the current situation, pandemic situation, what happens right now is that the healthcare workers, they get the details in Excel sheets and regarding travel information, and they'll have to go through that, or they'll have to go through an IT person to get to the details. And this cuts down, this takes up a lot of time, and we're planning to cut that down. But these two are within an organization. In the future scope, we are planning to put this out into the public. We are planning to interface credible and reliable information from big organizations like Walter's organization. I'm planning to interface to the regular public. Thereby, they can get credible information which is not seen in search engines, for example, which search engines give you results which may or may not be right. Now, I'm handing it over to my teammate, Gayatri Krishna.
Now, let me explain in steps how we are planning to implement the solution. So first you get the natural language query, which is mostly vague and unstructured. And then we map that query to a structured query language, which is abiding a slot filling model, the details of which we'll get into the next slides. And following the mapping process, we check if the user who's trying to access this given information is authorized to get hold of it. And it's only on clearance that we move on to execute that query and display that result. Now, what is a slot filling model? Now let's look at the slide, the left side of the slide, where you can see a question: who is the player that wears number 42? And now let's look at the right side of the slide, where you can see a structured query language which has certain slots in it. Now, the blue color slot is used to predict the aggregator operator, if any, which depends on the question, and that is done using the aggregator network. And next to it, you can see a pink slot, which is used to predict the column that we need to retrieve the information from, and that is done using the selection network. And finally, you can see an orange slot where you can see a condition that is specified in the question that further validates our answer, and that is done using the where clause network. Now, here we don't predict the from clause because the from is constant and we are only pertaining to a single table.
So I am giving an abstract details about the workings of the neural network. So as we have said earlier, we have 3 subtasks, out of which the first subtask is predicting the aggregation operator, which is done by using a recurrent neural network. For the recurrent neural network, we are using LSTMs. And after encoding the question words using RNNs, we apply attention over it and we aggregate them and pass them through a fully connected layer having 6 outputs. The 6 outputs correspond to the 6 aggregation operators, and this is how we predict the aggregation operator. And moving on to the column which needs to be selected, we also encode the question as well as the column names together, and we add the we pass the columns similar to the way as the columns, and then we add the question meaning representation and sum them up, and we normalize them, and we take the column which gives the highest score as the column which needs to be selected. And for coming to the prediction of the where clause, actually where clause consists of 4 subtasks, which we need to predict the number of conditions, the columns in each condition, their operators as well as the values. Each subtask is dependent on one another. So let us move on to the working of the number of conditions. For predicting the number of conditions, we need information about both the question as well as the columns. So we encode both the questions as well as the column names using a recurrent neural network as seen by this animation. And the main difference is we pass the initial meaning representation of the question as the initial hidden state to our RNN. And finally, we pass the output through a fully connected layer having 5 outputs. The 5 outputs correspond to the classes 0 to 4, which are the number of conditions which needs to be included. Now, coming on to the columns which need to be selected, actually we are doing a correlation analysis between the question and the words. We first do a correlation analysis, then we multiply it with the question and we aggregate them and we add them with the columns, and we pass the final output representation through a fully connected layer having number of outputs equal to the number of columns. We predicted the number of conditions in an earlier step, and we select the columns based on that. So in this way, we are predicting the columns which needs to be included in condition. And coming to the operators, we are doing the same sequence of operations as in before, but the number of outputs is limited to 3, which includes equal to, greater than, or less than. And for predicting the values corresponding to each condition, for predicting the values corresponding to each condition, we are using what is known as a pointer network, which is in the next slide. We are using a pointer network. So as for a summarization, we have adopted the first 2 neural networks, the aggregation and the selection operator, from a paper named Seek2SQL. And the where clause network is taken from the paper SQLnet. And this is an abstract idea of the working of our model.
Now, moving on to the tech stack, on the client side, or what the client sees, we've built our user interface using the web framework Python Django, and we've styled and scripted using HTML, CSS, and JavaScript respectively. And on the server side, we've built our model. We've developed our model using PyTorch, NumPy, and Matplotlib, among other popular Python modules. And we've also deployed another server for Python, for an API that is done using Python Flask, and we've deployed both of these on an Apache server. All right. Now, an API. Why did we use an API? Because we have to get word embeddings or word vectors for the corresponding words, each corresponding word of a query that we are entering into the input. And we used Python Flask to deploy this. Now, why did we use an API? Now, our word embedding file is stored in this glob file, which is around 5 gigabytes in size. And having to read through it every time and retrieving for each and every word is a resource consuming task. So we wanted to reduce the load on our server and also on the users or the client's interface. That's why we used an API. And also another reason is that if there are other developers who wants to extract word embeddings from the corresponding words, they can do that by using our service or our API service, which is hosted on Google Cloud Server.
Now, when it comes to the accuracy estimation, we have observed high accuracy when it comes to predicting the aggregation operator as well as the column that needs to be selected. Having said that, we did observe a limitation accuracy when it came to the where clause prediction, which was inspired from the SQLnet paper. And upon further deliberation, and since the first evaluation, we decided to implement another where clause model, which was inspired from SQLOVA, and we were able to achieve an improvement in accuracy for over 2%. And how we calculate as accuracy is using the logical form accuracy, which basically compares the query that we predicted with the ground truth, sums the result of all the test sets, and finds its average. Now, when it comes to the future scope, we have a long way to go. And the first step towards that would be to strive for a better accuracy for the model. Next, we'd like to extend our project to a software as a service model, which my teammate Praveen explained, where we can interface big organizations like UN, WHO to the public. Next, we'd like to implement some kind of a backend input verification, which is currently restricted to the front end. And next, we'd like to build a chatbot to enhance the user experience, where there will be certain query helpers that will help the user to better structure the query. And lastly, and most significantly, we'd like to extend the project to a multi-domain database where there'll be multiple tables and we can extract information from them. And that is the end of our presentation.
And before moving on to the demo, I would like to some facts. We are not yet at a stage to fully understand natural language, but we have with using our algorithms, we are able to about to approximate the natural language understanding part well, and some queries might work, some won't. The reason is we have not used any contextual means of representing each word. So our product is currently only in an alpha or alpha stage. It is only a prototype. We are working on getting more context sensitive embeddings using a contextual model, which is a recent advancement technology, and we are currently working on it. So my teammate Praveen will be going through some of the major highlights and some of the queries which worked and which normally won't work when we are adopting a keyword search based approach. So Praveen will be going through it, and now I am handing it over to Praveen.
Thank you, Jacob. So just give me a minute until I share my screen. All right. So as you can see, this is the UI that we developed using Python Django framework.
Okay.
Am I on mute? No, can you see it?
Yeah, no. Yes, I can see it.
Okay, cool. So before we start, let's take a look around the UI. And it's a very simple UI because we plan on making a flat learning curve for this. Because just by taking one look, people will understand what it is. And if they need any help, they can actually use the top right-hand corner or the help page where we describe what the software is about, why did we make this, a little how-to guide as to how to go about the database, a little bit of guide, and a bit of the technical functionalities. And if you want to know more about in technical detail, you can see over here, or you can actually view the demo, which is around a 2-minute video. So let's actually go back and start off with the demonstration. But just for the purposes of this demo, we have put in 2 tables, which are test tables, which contain test data. I'm reiterating this. This is not official. This is just dummy data. And we have an option to choose a table over here. Now, why are we choosing a table? There's a little info bar on the side that says that we can select a table so as to view the schema of the table, so as to know how to structure our query. What I mean by that is that if you take employee details, for example, and you'll be able to view the schema over here, and you can see a small description that it contains the details of employees, and you can see what all are the fields in there so that people can ask queries in such a manner. For example, let's say I want to find out what department my friend Jacob is in. So I'm just going to type in, excuse me, a question that says, what is the department of Jacob? And I will choose the employee details table and I will hit search. And on the output page, we will be able to see the question that we entered, the output with an option for us to copy the answer to the clipboard and we can paste it. And also for the purpose of our project and for the demo, on the top right-hand corner, there is a toggle on the navigation bar to view the structured query language, which we generated from this unstructured natural language. As you can see, select department from user, employee where name equals to Jacob. Now the thing is, okay, I'll get to that. So this was a basic question. Now let's actually ask another question. Let's assume, say I want to see the salary of Jacob. So I can type in something like, what's the salary of Jacob? And I will choose the table, employee details, and I will hit search again. And this time I will get a prompt saying permission denied. And even when I view the SQL, I won't be able to see it because this is how we are performing access checks. Salary is a sensitive column within the employee table. And we have performed an access check where only authorized personnel can view sensitive column data. So if you are an admin, or if you're a person who's authorized to view it, you can sign in using the sign in page. You can log in. And once you have logged in, you will be able to see that your admin privileges are active. What it means is that you now have access to sensitive field data. So now if I ask the same question, what's the salary of Jacob? And if I choose the employee details table again and hit search, I will be shown the answer with the SQL query over here. All right. Now, the thing is, since it is natural language conversion, what we can do is we can, put any other, because my natural language is not my teammate Jacob's or my
You've
teammate.
got 3 more minutes, please.
Yes, that's not either of our natural languages either. So let's say Gayatri is going to ask in something like, how much is Jacob paid? And it's the same table. And when I search for it, you get the same answer despite being the sentence structured in a different way. Now, another thing I'd like to show is if I want to get the contact information of Jacob, I can type in something like get the contact of Jacob. I feel like I'm overusing Jacob, but just for the purpose of this demo. And I'm going to search in employee details. And obviously, this is a test number, but we will get the phone number. Now, another thing I'd like to show is that we can use the same query in different tables. Now, even in COVID-19 database, if you look at the schema, you can see that there is a phone number present here. So I can type in the same query, that is get the contact of Jacob. And I will search the COVID-19 database. And it will return the same answer.
We have not used any column words because keyword searching, we have not adopted any sort of like that.
Yes. And also for the aggregator operator, we can search in something like what's the least age or what's the average age, for example, in the COVID-19 database, which is very relevant at this point, and we will get the average age from the table. This is the average age, the aggregator predictor, and also we can search for the least salary from the employee table. What's the least salary? And we can search that in the employee details table, and you will get, no, did not hit search. And you will get the average salary, that is min. We did not use min, we used a synonym least, and the model was still able to predict that. Now, if you want a list of outputs, we can get that as well. Show every person's name. This works for both databases. And you will get an entire list of names. And also right now in the, if you want to select the passenger's information, what right now in the current situation it happens is that the health department gets it as an Excel sheet and the health workers are the ones who are going through this Excel sheet. So some people may not know how to use it properly and that will cause a lot of time delay. So if you want
Your
to...
time is up now, so please wind up.
All right. Thank you, sir. So with that demo, that's how I'd like to end it. I hope I was able to, or we were able to give you a brief about our project, and thank you for the time.
Thanks very much for the presentation. Can you take us to your code, please?
Yes, sir. Give me a minute. So do you want the front end or the back end?
Only the back end.
Okay.
Show us the form handling part.
So the form handling part has been done in the front end. That's what the input verification is actually being done only in the front end as of right now, which we plan on making it to the back end. But I will show you that in just a minute. Let me just share the screen. Okay. Is it visible?
Yep.
So this is the home page, and over here is the one where we are doing the form handling part. And over here in the demo, we've seen the search bar, right? So in the search bar, we've given a few constraints as to what input is accepted, and that is actually given as a regular expression pattern over here. But that's what I was talking
about. The logic, forget the validation.
Okay.
So where is the actual query being made?
Okay.
Being made?
Jacob, that's the backend. Jacob, do you want to take over?
Yes, it's in the.
I thought I asked for the backend.
Yeah, yes, sir. But the input verification was in the front end. My bad. Jacob?
Yes, in the interface.py, we do have that file. Yes, so as in line number 28, we have initialized the model, and our model actually consists of 3 submodels. One for, as we have said earlier, the column which needs the aggregation operator, the column which needs to be selected, and the condition. So down. So this is only a rough implementation. We have not added any front-end components to it, and we have used a sample table that's columns are shown in line number 14, and in line number 46, we are selecting the index of the aggregation operator. In the line number 42, we get the index of the column, and where clause query actually it consists of 4 tasks. So we actually wrote a separate function in a file called utils.py, and that generates the conditions of the gen query accuracy. And we combine all of them and we return the query. So gen query accuracy. Search for it, gen query gen underscore query accuracy underscore query. Okay, that's, and we get the conditions as a list, and for each condition we get the corresponding operator, the index of the column, as well as we are adopting a pointer network approach for selecting the values. So the words in each condition is usually taken from the question, and in this way we generate all conditions, and we finally append them, join them using and condition, and then we return back to the interface.
Can you show us the step where the inputs from the query in the front end gets converted through a function call to the actual SQL query?
That's the front end part, I think.
Front end? Why should it be the front end? Because that's handled by Flask, right? The arguments are coming behind to the back end.
So do you mean how we are how are we retrieving the data from the database?
No, I want the location where the model is being queried with the arguments received from the front end, and you get back the SQL statement.
Okay, cool. So in home.html, you get the form input, and
Praveen,
yes.
If we understood you correctly, so you have 2 components. One is so from the front end you have the question there, and then you're going to use certain keywords, or you're going to use a sentence with an LSTM model, or any of those, one of those RNN models that you're talking about, right? And after it passes, how do you end up getting the words that are to do with SQL or the entire SQL statement, right? So the input is, what is the input? Is it the sentence, or is it words extracted from the sentence, right? And then it passes into a neural network model, and then what comes out, is it a bunch of words, or is it a sequence of words like a full-fledged SQL?
Okay.
Summarize that and show us where it.
Okay, so we get the sentence from the input form on the front end. Okay, and we by process, Jacob, do you want to take this over? Processing the statement. This is how we.
You continue. processing sentence by meaning we remove any stop words or punctuations like that, and also remove apostrophes from question words, and then we split them and convert them into lowercase. Normal natural language processing task which we do, and then we split
And
the
you
question.
tokenize, and then the tokens are used, is it?
Yes, the words are split based on a white space, and tokens are used. And for each token, we extract it embeddings and pass them through the neural model.
So
For
what
each
is that happening?
particular task, that is what is happening. As in, if it, for example, if the operation is to find the aggregator operator, first the question is entered, and the aggregator. So there is as we mentioned, there is a slot filling model, and that's how it's printed in the actual area. And the aggregator model function is actually called, and the question is given as an input, and that question is converted to its corresponding question representation, which is done using LSTM and certain attention mechanisms. And it is using that attention representation that we find whichever is the appropriate aggregator operator, and we send the scores back to where it was called and find the aggregator operator that has retrieved the highest score, and that is what gets printed.
So
I don't think the question has been answered at all, but I'll defer to my other colleagues on the jury to kind of further I'll take this forward.
So, Gayatri, if I understood you correctly, there are tokens that are passed into the neural network, right? And then you have probable words that are associated with, in a context of SQL. What are those words is what you get, and then you pick those words and put them together, right? That's the slot filling part that you're talking about, right? And I kind of got this right now. What is that? What is your training data, and how did you evaluate the model?
So the training data is actually we've taken the data set from a very popular data set called as WikiSQL. It's been made by Salesforce, and it's a very popular data set where problems of this sort are being evaluated for. And that data set it's been divided into training, test, and validation. And that is where we got the training data set from. And the training was done using the cross entropy loss.
Is it a pre-built model, or you did the training? How much?
No, we
run?
Sorry. Actually, we adopted ideas from many models. We began to read more papers regarding this task, and we found 3 models which we could easily implement. And we referred these architectures, and we built it from scratch, and we trained it on VM.
How long did it take? What kind of hardware did you use?
It because we didn't use any sort of contextual models, we were able to train for each epoch. We took about 5 minutes or so, and the model converged at an epoch of about 15. That was when the validation losses of all the models were minimum. So we were considering each model separately, and we saved the model checkpoint when their validation losses reaches a minimum than before.
15 epochs might be too small, isn't it? So what was the loss at 15 epoch?
I don't actually remember but I
roughly directionally. I don't want a precise number, like 80%, 90%,
no,
95%.
The loss was about 0.8 or something. I don't clearly know, but the
0.8,
model which last converged was the selection operator. The column which needs to be selected, that aggregate neural network was the last to converge. The first to converge was the aggregation operator. It converged about third epoch.
Okay, so can I ask you one thing? So this neural network architecture was a predefined one, or you added layers and did all of that?
Yes, we combined approaches from 2 papers. So it's actually not from a single paper. So our first 2 networks, aggregation and the selection network, that is taken from the paper Seek to SQL. While the third one, the Workflows, is from another paper. It is from a paper named SQLnet. So we have adopted a hybrid approach.
Can a couple of last questions? I really liked your user interface for its simplicity and the look and feel. I don't know because I am colorblind. Right, I have a serious problem judging on it, but I think it was fantastic. That it was very simple, right? Almost like Google, right? And how did you end up choosing this topic, right? Because anybody in the neural network world, uh, and who came from a DB background ended up trying to do this always, right? And many times they failed. Some of them have been successful. What inspired you to actually pick this topic?
Actually, real world info is usually they are accessed in a more constrained way. Like end users don't have a good control of the read-only information that they want from a database. Especially even in the case of a website, if you want to know some information, like any read-only information, a developer has to code everything from scratch, and he has to get understand the UI, get more details regarding into it, and it becomes a very large task for a developer, and it might take time till the information is out into the public for uh, public. So what we, by using such interfaces, natural language interfaces, what we can do is we can easily deploy such read only and public informations easily without going through any construction of any web app. Just we can use this simple interface and we can get the information that we want. That's the primary motivation that we had while we started to take this project.
One more thing I'd like to add to this is that we, ever since this project came on board and we were on the implementation, the COVID-19 pandemic was also going on, and we did get testimonials from doctors who are in the front line of this. And one of them had said that right now all the COVID-related data, they come at Trivandrum, the DHS at Trivandrum, and what they have, and the doctors are really struggling to filter through those data because they do not know the basic Excel sheet tricks and formats. And what they're doing now is they have a couple of engineering students who help them through the process, and they are genuinely struggling. And that is when we clearly understood the relevance of something easy and simple as this.
Fantastic.
Right. So I think we have a time constraint now. So Nilangan, do you have any? Okay.
Can I ask one last question? So
Okay,
you
sure.
have Django and Flask. Why did you use both of them? You could have used one of it.
That's right, sir. So the reason I use Flask is because an API did not, all we did was we give the input of a word and we get the output as a JSON format. So for this, Flask seemed quite easy to develop for a prototype, and we didn't want to combine all of those.
Yeah, you have Django REST framework as well, but it's a little complicated. But I think
Yes,
it's
sir.
worth just merging them using one of those. Thank you.
Thank you.
Right. Any other questions, Nilangan?
Second, I don't have.
Okay, so thanks very much for your presentation. We will get back to you shortly.
Thank you so much for the opportunity, Hamid.
Thank you, sir.
Thank you.
Thank you so much, Steve. Now you can leave.
Thank you once again.
Bye.
Now judges can move to discussion room, and we'll be having a short lunch break, and let us all be back by 1:45.
Hello everyone, welcome back. The CSI InApp National Student Project Awards is an annual event that involves a 6-month process, starting from the call for applications to several rounds of evaluation. This year, we had a little over 2,500 students from across the country, representing 96 colleges with a total of 571 projects that were presented. Further, to this competition, we feel it would be very useful and appropriate for a large number of enthusiastic students to gain insight from rich interaction with accomplished people from the industry as well as academia. Therefore, it would be a pleasure to announce a 3-day webinar series starting from July 2nd to July 4th. Topics like entrepreneurial, data science, biomedical engineering, and bionics will be discussed by eminent speakers. We are also planning to host a panel discussion on the topic Reimagining the Future of Education with eminent panelists from academia and the industry. More on that later. Is everyone in from your team?
Yes.
Okay. Okay, before we start, let me tell you something. Out of the 30 minutes allotted for the presentation, 10 minutes is for presentation, and the other 10 minutes is for the demo, and the rest 10 minutes will be for the question and answer session. Okay. Please keep up the time. Next, we have a first afternoon presentation session on the topic automatic depression level analysis using audio-visual modality by another team from the college, PS Modern College of Engineering, Pune, Maharashtra. Judges, can we start the presentation?
Yes, please.
Yeah, you can go ahead with your presentation. All the best.
Okay. Good afternoon, everyone. We are from PS Modern College of Engineering, Pune, and we would like to present before you our topic, automatic depression level analysis using audio-visual modality. I would like to thank you for giving us an opportunity to showcase our project in front of you. So depression is a mental disorder which is quite common in today's world, and a lot of people are facing this problem. It affects a person in a negative way, leading to anxiety and panic attacks. Next, please. It is every time not possible to go physically to a doctor or a psychiatrist to show like what problem exactly we have, because it's a very lengthy process. Thus, we have automated our system using ML techniques so that an early detection of that particular disorder can be possible, and then accordingly steps can be taken. So we have used ML techniques to automate our process, and we have 2 streams, visual and vocal streams. Next, please. So in our system, there are 2 streams for visual and audio prediction. Basically, facial expressions and vocal expressions. These 2 are the most contributing features to the emotions of a person. So we have considered these 2 features. In visual prediction, at the end of the stream, we get a single value. And also after audio prediction, we get a single value, after which both the values are combined using prediction level fusion. And then a final value of depression is obtained. That final value of depression ranges from 0 to 63, where 0 being the least depressed and 63 being the most depressed person. Next, please.
I would brief you about the implementation step. So the input to our system is the video, which is then bifurcated between the audio and the visual streams. So in visual stream, we are extracting frames, and for audio, we are extracting wave file. The next step is feature extraction step, in which for visual, we have used VGG phase for extracting the features, and for audio, we are extracting MFCC, ZCR, and STE features. By using the extracted features, we are generating the dynamic features, which are basically the temporal movement between the features. For visual, we are using FDH's algorithm, which is modified a bit by us, which we will explain you in the later slides. For visual, we have performed dimensionality reduction by using SVD. The next step is the regression step. For audio, the audio stream is divided into small segments, which are then passed to regression. And for visual, we are just performing linear regression on it. Both these modalities would generate a particular BDI level, which is basically the depression level, which we will combine by using a method from prediction level fusion and generate a particular value for that user. That is a depression level for that user. So this is an architecture diagram. Initially, the user will register by entering his credentials, and then after login, he would submit a particular video, and then the processing step will start for both the modalities, visual as well as audio, that I mentioned you before. Then a particular BDI level, that is the depression level, will get predicted, and a report for it is generated, which then gets stored in the database. The user can view his previous 2 reports from the history tab.
Our contribution in the existing system is there's one dynamic feature extraction algorithm, which is feature dynamic history histogram, FDHH. We improve the algorithm by adding a condition. The condition considers the last pattern which was skipped by the algorithm earlier. The second improvement we made is feature selection for visual. So there are patterns, there are 10 patterns, and we evaluated each pattern individually regarding the prediction, and we considered the best giving result patterns. The third is most of the paper select MFCC as feature extraction, only MFCC, and we added 2 more features, which is ZCR and STE as an additional to enhance the result of audio. Last is segment-wise regression. In audio, we perform segment-wise regression, in which 16 frames are considered, and the segment is of the length 16 into 18, which is 18 is MFCC, 16 MFCC, and 2 ZCR and STE features. Next, please. We used AVEC 2014 data set. AVEC is a challenge, audio visual emotion recognition challenge, in which they provide a data set every year to study depression and to find depression level. It consists of 300 videos, in which it is segregated into 3 parts: development, training, and testing, which contains 100 videos each. There are 2 tasks performed in this video, Northwind and Freeform, which we will explain it later. And the length of the video clips ranges from 6 seconds to 4 minutes 8 seconds. The BDI2 depression scale is considered for mapping the features and to predict the depression level. The BDI2 is big depression inventory, which has the scale of 0 to 63, 0 being the least depressed and 63 being the most depressed. And BDI2 is the self-explanatory questionnaires, in which the user get the BDI level by giving the answers of the question. Technologies which we used for development as PyCharm as a platform for development, Python language for development, and libraries which we used are TensorFlow, sklearn for linear regression, Librosa for feature extraction of audio, Keras VGG phase for feature extraction of visual, OpenCV for frame extraction, Kinter for geo extraction, and etc.
Okay, so here are the results which we have obtained from our methods, which was explained by my colleagues. So as told you earlier, we have 3 sets in our data set, like the development set, the test set, and the training set. So we have trained our process, we have trained our system on the training data set, and then we have tested our system separately on the development set and on the test set. So here also we have three sets of results presenting before you. So for audio modality to be tested alone, we have two predictions. Like the development set has 9.9 RMSE and the test set has 9.3. For the visual modality alone, we have 9.22 as the RMSE of development set and 9.4 as the RMSE of test set. And the combined process, which was explained earlier, we have the RMSE of 9.11 and the test of RMSE of 8.8. Okay, so to note you one thing, these are the results only for the comparison purpose. And then we have developed a standalone system in which we have trained our system on the 90% of the data, which was explained earlier. And then the results obtained were quite promising. The results obtained were 7.7 RMSE and MAE was 5.2, which was quite promising again. So for the application side, we suggest that our system could be used in many ways. First of all, we can use our system in any kind of organization in which the employees are tested on our system, and on the basis of that depression level, their performance is checked. Also, we could use our system in schools and colleges where students are conducting regular health checkups, in which we can add our system to check the depression of them as well. And also, we can use our system for any user. Like many of us have ability to go to routine health checkups, so we can include our system in that as well. So the concluding part, the results of our system are far more better than the all existing system in terms of RMSE. In terms of the single modular system, like only the audio module had shown remarkable results in the existing approach. For all the other single modular systems, and the whole system which we have developed earlier is like training on the 90% of the data set has achieved good results. Then for the future scope to further improve our system, we have used VGG face pre-trained model to get the visual features. So we can give more images to the VGG face and get more accurate results. And also in place of regression, people can make use of deep neural networks like CNN to perform the task of regression. So thank you. We would then now like to show you the demo of our system. Okay, so here is the code of our system. I would narrate you through the same. Okay, so here is the introduction page in which we have specified the user that how the input should be. Like the user has to submit 2 videos. In first video, he should read a paragraph of more than 200 words. And in second video, he should narrate any happy and a sad memory of his choice. So this is the input we want. Now we have again 2 features like the registration and the login process. I will quickly show you the registration process. Okay, the user has successfully registered. Now I will log in through that credentials. Okay. So here is the main page. The reason that we have added the name and the email field again is that not only the user having the system, but the user can test the depression of many of his friends or colleagues he wants. So the person going under through the depression analysis should enter his name. I will write user again. Okay, so these are the 2 videos which the user should submit. Now for the demo purpose, we have taken 2 videos from the dataset in which the videos are freeform and the Northwind. Okay, the freeform and the Northwind compartments are explained earlier. Like the freeform is the same task which we have explained earlier. Like the freeform is a user has to read aloud a passage of 200 or more words. And in Northwind task, the user has to narrate any memory, happy and a sad one. So after submitting, the result will be started. So I can show you the, okay, the files are being generated. So here train free audio and train free audio one are the wave files which we have generated. Like these are the files of the audio data extracted from the video. Now the Excel files are the files which we have used to store the features which we have extracted from the video. And also we have used some more Excel files to store the dynamic features which we have calculated then. And the frames which you are seeing are the frames being extracted from the video itself for the visual frame which was explained earlier. And okay, so after the, okay, these are the again Excel files. So as the process is completed, depression level is displayed on the screen. We have another facility of report in which user can see his report. In the report, the user, we have displayed the depression level, the age and the name of the user. And also we have displayed the classification of that depression level. Like for now, the user has a depression level of 12. So he can classify his depression level in mild mood disturbance, as shown earlier. So accordingly, the user or the system which the organization is using can take according steps according to the depression of their employees. Again, we have another facility of history tab. Okay, so the history tab, as we have registered now, the user only contain one history of his depression level. But if the system is tested again on the same user, another history entry will be added in the history tab. And also he can open his depression level from the history tab itself. So yeah, that's all for the demo side. If you have any questions, you can go ahead with it.
Thank you very much for a very interesting presentation and demo. And I like the fact that the presentation was organized very well, highlighting specifically the contributions that you have made, which is important. I have a clarification question first. You seem to be recording the history, but of course, I see that one user can potentially use the system to find out about multiple friends or whatever. But if you had an individual user using only for himself or herself, I find that the analytical system is not considering past history. So if a person is already depressed, would that influence your results in any way? So there's no loop back. Do you understand what I'm saying? If a person has already a history of depression, it is likely that that same person may be depressed in future also. But your model does not take care of that.
Okay.
So do you have any comments on why it is so?
Actually, we have used our system, like the application of our system is for the organization. So the user going under through the depression will have the history of depression resulted in that history tab itself. Like the organization can take certain measures on that history or on that report of depression which the user has.
That's not what I meant. Your analytical model, you have, for example, you're splitting the incoming stream into audio, video, and then you're doing a series of steps. What I'm saying is that someone with a history of depression earlier, you're not taking as input into this system because it could be a correlation. If you go to a doctor will ask you were you depressed earlier, because if so, then you are likely to be depressed now also.
Okay. Okay, so for now we are only testing the present depression level of the system, but yeah, we can take account the suggestion. So we can also take the user, but for my side, like I might be wrong, but from my opinion, the user always tend to neglect the depression or just deny it. Like even if we have asked the user should quickly tell that he has no depression history, even though he has the one. So
We are not
that could
talking
affect
about
our
asking
model.
the user. We are saying that the user's information is already there in your system. So anyway, so that's one comment. So I will open up the floor for questions from my colleagues. Please go ahead.
Just adding to what Satish said, right? That's such a very, very important thing, specifically for a healthcare application like this. I will just give you a scenario when insurance companies collect information, right, on what your health statuses are. Like, do you have history of heart disease.
Okay.
Do you smoke, right? The moment you say smoke, it means that you're likely to have higher chances of certain kind of diseases, right? And that's why they collect that. That is exactly what Satish is talking about, right? So if you had history of depression, there is a higher probability. You need to go and explore a field called Bayesian statistics. Bayesian statistics and conditional probability. That is, if you're into data science and you want to do that, I think you should definitely go and spend some time on it. And suddenly you start understanding what Satish meant, right?
Okay. Thank you.
So now coming, I have a couple of questions. You said for regression you use CNN. Why
Yeah.
would you do that?
Like there are various methods for which CNN can be used to do the work of regression. That depends on the data. Like CNN can predict more accurately than the linear regression itself. But
Is CNN typically used for what?
it can be used for the regression purpose. Like the task which the regression is doing can be done by the CNN.
Yeah, CNN usually used for computer vision, right? But there are scenarios where you would do regression, but why would you use CNN for regression? Any reason?
Like it can predict better than the linear regression. Like if we have data set which was way larger than we thought, so then we can make use of CNN to calculate all the features, like calculate all the things which linear regression could not.
Yeah, so I will come back to CNN because it depends on how you structure your data, right?
Yeah.
And
Yeah.
otherwise CNN you would not use CNN commonly for regression unless you have a very special kind of structure of data. And you said RMSE and MAE you have about 8, right? Around 8 or something, right? How did you benchmark your model is better than others, right? And what have people achieved while doing research, or if there is a commercial product, something similar to this, what is their RMSE values and MAE values? See, unlike other metrics, if it is percentage accuracy or if it is something to do with percentage, it's easy to relate. RMSE is a very different metric, right? How did you say your models are better? Can you substantiate that?
Yeah. So the models which we are referring earlier had the RMSE values and the ME values, which were compared by a whole lot of researchers. So
Can you give me
like
one
you just
example? What your current RMSE is? Can you tell me what is your RMSE?
yeah,
8
I
something?
will just show you the slide again.
8 point something.
Yeah. The
What is
RMSE of the model is 7.7 and MA is 5.5. And
5.5.
currently the process of like the paper we are referring was someone, Asim Jan. He has the RMSE of 8 and MA of 6.7 or something. So in terms of MA and RMSE, we are like ahead of them.
Okay. So your errors are lower, right?
Yeah.
So that's what you claim. Okay. And what are these RMSE values and MAE values for? So there is some model that you ran, some regression model. What is that regression model's output?
Okay. So do you want me to like explain the
No,
RMSE process,
I
like
just
how
need
to
to know
calculate
what you're
it?
predicting. What are you predicting?
Okay, so in our data set, we have like 100 videos for test and train. So we are predicting BDI level for all the 100 users.
Okay.
And then we have actual BDI level of those users through which we can map the RMSE.
Okay. And what is the training data set that you use? What is something from the public domain?
Actually, we
AVAC
have
2014.
used data set from ABAC 2000 challenge, like
Okay.
2014 challenge.
Okay. Okay. And the state of the art, um, accuracy you said was the paper that you referred, which is 8 and 7. Okay. And so now, so coming back to CNN, right? Why would you use CNN for regression? What is your input data? What is your output data?
Okay, so earlier we referred a paper in which they have used CNN. Like for audio, we have not calculated our features, and then we have extracted dynamic features from them, and then directly we are giving it to linear regression for now. But we have referred a paper in which they have kept the original features along with the like the dynamic features, and then as the data set is more, they have given it to the CNN to calculate their BDI. like to calculate a single value.
So did you build the model, CNN? Did you build the models yourself?
Okay,
Was
for
it-
now we are now using only dynamic features. Like we have built the model for both the like original features and the dynamic ones.
Yeah. So
but our
what package did you use for building the model? Keras, PyTorch, TensorFlow?
Keras.
Yeah, Keras. So now, what kind of convolution layers did you use? Conv 2D, Conv 1D, what kind of it?
like for the model which we are using right now, or for one which
For the model you said, see, I'm trying to understand why would you use CNN for regression? That's not a common thing, right? You use in very, very specialized scenarios, right? So that's why I'm trying to figure out what is in your neural network, right? Is it Conv 1D, is it Conv 2D, or something else?
So we have used this VGG phase for feature extraction, which
And
basically
feature extraction is different.
no. So which returns 4096 elements. So we could use those elements and give that to the neural network for instead of doing it with regression.
Yeah, correct.
So that's what we
So my
meant.
point is that, right, when you extracted from VGG net, VGG face, you extracted how much? 512 features? Your voice was not, we couldn't hear anything what you said because I think bandwidth has a problem. Is it 512 features that you extracted from VGG face? Could you repeat that?
Yeah, so we extracted facial landmarks from the VGG phase, which were 4096 per frame.
Okay, 4096 per frame. And so that's a feature vector that you have, one vector,
Yeah,
right?
yeah.
And now you use that for what?
Yeah, so after that, we computed dynamic features from which we got patterns.
Okay.
And then those can be given for deep learning network.
Yeah, but you don't know what the architecture is like. You don't know. So you said, he said CNN is what is used. What are the layers containing? Con 1D,
Yeah.
Con 2D, etc.
Yeah, actually, we are using the sixth layer, like 32nd layer of the VGG pre-trained face model.
That's different question. So that is for feature extraction. So your team is saying after feature extraction, it is passed into a linear regression model, right? And the linear regression model is supposed to have, linear regression model in this particular case is CNN is what your team is saying, right? And
no. We can make use of CNN, like the linear regression model.
In your case, what did you use?
We have used multiple linear regression for now.
Multilinear regression. Okay, thank you. So my whole question was that, right? So why would you use CNN? Okay. I think it's a nice project. It's a fantastic project, right? But there is a big limitation in developing anything around healthcare, right? What are that limitation? If you were to make it commercial, right? Have you thought through? Because I could actually hear you say that, people can just take this test, right? That's not how it works in healthcare systems, right? It needs proper approvals. But have you read through that, right?
No, actually, like we have not thought that through, like how will we commercialize.
It's a good thing. This is you people are doing the technology side, very fantastic, right? So I think if at some point in time you want to take it to a commercial level, there's a lot of norms, and that needs to be taken care of. And you should continue doing this. Very nice work. Little more depth in terms of the technology is required. And you need to get into what different neural networks are, right? And what layers are used, what algorithm is used when, right? I think a little more clarity is required. But otherwise, I think it's a nice project, right? You've explored many, many things like VGG phase and many, many other things. Fantastic. Good, right? And that's all from my end.
Thank you.
Thanks very much. And then, Nilkandan, do you have any questions?
Yeah. I know that there was no formal clinical trials made, but have you made any informal kind of trials with this?
Pardon?
No. Did you make any trials, any practical evaluation of your system? I know that there was no formal clinical trials, but informal.
By the term informal, you would mean to say? Like, can you give us an example?
Okay, you have some already evaluated patient or evaluated videos or something with real with clinical support, no clinical background,
Okay.
real clinical data, and you put that video into this system and how this system came out.
Okay, so like we have used BDI scale, like for this users which we have tested has taken the BDI test for themselves, and they have self-evaluated themselves. And with that evaluation, they have given their depression level for which we have tested. But apart from that, like apart from data set, we have not consulted anyone for like the testing purpose.
Okay, okay, good, very good work. Yes. Okay.
Any other questions? If not, we'd like to thank you for your presentation. I think it's a very important project and socially relevant as well. But there are several steps before you can commercialize it, especially because medicine is a very tightly regulated domain. So thanks very much, and you can now leave.
Thank you again for letting us present before you.
Thank you so much, Steve. You can leave. Have a nice day. Judges can now move on to the discussion room, and we will have the next presentation at sharp 2:30.
I don't see the link. Yeah, okay, it's come now.
Hi, Aishwarya. Is everybody in? Hello, is everybody in? So before we start, let me just give you some introduction. We have 10 minutes for the presentation, 10 minutes for the demo, and the 10 minutes is for the question and answer session by the judges. So if you have any problem with the connectivity, please turn off your video. And please make sure that you unmute yourself before you present. Now, let us move on to the last presentation for the day. Next, I would like to invite the team from TOCH Institute of Science and Technology, Kochi, Kerala, to present their project on the topic, Machine Learning Integrated Hero Arm. All the best, team. Go ahead.
Thank you. A very warm good afternoon to one and all. First of all, we would like to thank CSI InApp Student Project Award 2020 for selecting our project to the final stage. Before getting on to our presentation, I would like to introduce my team members, Ashika Chinushabu, Anne-Marie Tom, Mohammed Sahil, and myself, Aishwarya Sen. Hands are one of the most important organs in our body. An amputee is a person who has lost all or a part of an arm, hand, leg, etc. by amputation. Unfortunately, at this point of time, there are a lot of millions of people who suffer from amputation, out of which a lot of people have below amputation. Amputation not only affects their survival career, but it affects them emotionally. Many of them lose hope in life. Our proposed solution for the amputees was the bionic arm. Bionic arm is the best revolutionary idea an amputee can have. The purpose of the project is to make a functioning, comfortable, and affordable prosthetic limb for the amputees who can detect and pick various objects. Object image was captured using a camera. Object classification and orientation was done through deep learning. The fingers of arm provide proportional control and multiple grip nodes. The major goal of our project is to address the deficiency of the low-cost, high-functionality devices in the upper limb prosthesis. Problem identification. The patients who are suffering from injury on the upper limb, they will be unable to move the arm normally. The inabilities may cause inconvenience for them to perform daily routines. And in this case, many of them lose hope in life. So before getting on to our project, we did a feasibility study. Our economical feasibility was, it was molded from PLA. It was a biodegradable filament, which is a lightweight, but it's a tough material. The Arduino is a low-cost credit-sized microcontroller, and our overall project was scaled to 10,000 to 15,000, but we were able to complete it less than 10,000 rupees. The technical feasibility was the main challenge is to identify and pick the objects. For that, we use the deep learning algorithms and computer vision techniques. This is our high-level design. So we can see here there is a user intention. And after activating the camera through the image acquisition and pre-processing, we'll be able to use the classification and orientation detection codes, where the processes controller will be having a grass detection. After identifying the particular grass, we'll be able to pick up an object. Next. So next, Anne will continue with the slides.
Good afternoon. Our StellarArm has mainly 3 modules, that is image classification, object orientation, and ARM design. So here's the implementation status of the modules. That's the status is 3 of them are 100% completed. Coming to module 1, it's image classification. Classification of objects to pick is done and dataset is created. Dataset includes more than 2000 images for each object, and we select it for picking. We have 3 program codes that is written in Python: dataset creation, training of dataset, image classification. We are using a simple CNN architecture, and for data splitting, OpenCV library is used to perform multiple operations. And the basic steps involved are import libraries, generate the data, make a neural network, data prediction. So here are the selected shape. That's a cylinder, box, and a ball. Okay, here's the code for dataset creation. And now the output of the dataset creation. Here's the program code for training the dataset. Output for training the dataset. Program code for image prediction. Determining the object captured. Coming to module 2, that's object orientation. The orientation of the object is calculated to get the grip nodes to pick the object. As orientation coordinates varies, the grip to pick the object that also varies. The finger movements of the arm that depends on the grip calculation, and code to calculate the orientation of the object that got trained using training data set. Now it's a program code for determining the object with a different orientation. Coming to module 3, it's ARM design. Fusion 360 is a software that is used to create the model for 3D printing. It provides a very intuitive assembly interface for changes to make it easier. It's a cloud-based platform and can be accessed from anywhere. The material used for 3D printing is PLA, and the parts will be the parts were printed separately. The parts are integrated, then motor and sensor are installed and wired. Then design model of the arm was printed at FabLab Kalamasheri, and the design of StellarArm is flexible for modification. Okay, here are the design and renders of the StellarArm. The entire process that ranging from the design and design to manufacturing of the StellarArm that was completed with a constrained low budget of 10,000 rupees. And the design is done in such a way that it can be modified to suit various amputees, their complex tasks or functions. And specification of the StellarArm is that it provides a lifelike appearance, higher comfort, and it can perform various active movements. Okay, the hardware used, there is IR sensor, infrared sensor that is used to detect the aspects of the surroundings to pick the object. And 2 motors that are used. Since it is a 2-finger system, there are 3 degrees of freedom. That's a finger movement, a thumb movement, and wrist movement. So the 3 motors are required. One is at finger, one is at thumb, and one is for the wrist. The Tauta SG92 are mini-servo motor. They are used for finger and thumb grips, whereas Tower Pro MG995 Metal Gear servo motor that is used for wrist grips. Okay, here's the implementation details of our project. Within 4 weeks, we completed, we just made a study, and in 8 weeks, we completed object identification. And on 12th week, we had done design, and 16th week object orientation, and 20th week parts integration, and on 24th week, the object grasping. Sahil will continue with the presentation. Thank you.
Good afternoon, everyone. Working. Coming into working, we have connected ground and VCC of motors and sensor to a breadboard and provided the power supply from a 9-volt battery. And we also connected the output pin of the motor and the IR sensor to the Arduino. Next slide. These are some of the images of the ARM after integration. This is the image of picking up of an object like a bottle with a simple grasp and release. This is a picking up of object like bottle along with the wrist rotation. We are successfully able to pick various other objects like a box, a cylinder brake box, and the coming into advantages of stellar arm. It is cost effective, independently moving fingers with firm grip and perform active movements, provides a lifelike experience and higher comfort, durable and performs basic functions of body powered processes, flexible to modification and lightweight and environment friendly. User controls the entire process with aid of shoulder grid and upper body. It provides the electrical and mechanical safeness of the design. Coming into the future scope, to develop a toe-operated control system, redesign the mechanical packaging to further reduce the size and weight of the system, complete assembly of full hand, improve the flexibility and accuracy, increase the number of operations. Coming into the conclusions. The goal of the project was to consider the design of the processes as something that could become a real product and not just a fancy tool. Amputee struggled to manage his or her everyday activities with much serenity as a physical fit person would do. There is a clear deficiency of low-cost, high-functionality device in the upper limb prosthetic market. Our project succeeded to produce a bionic arm that has a similar functionality to the most expensive hands available at low cost, dramatically lower than the least expensive hand. Thank you, everyone. I will.
Now, starting with our demo, we are capturing the images of the objects first. Then we will transfer this image to the orientation detection part. And the orientation detection part will send the control signal to the Arduino. The Arduino will send the control grip knobs to the fingers of this arm, and it will automatically pick the objects of the object which is captured. So this is the demo part which we are showing now. Starting with the object detection part. There is nothing here. So this is the frame which we created here. So this is a program code running to identify and classify the image. Here it shows us nothing. The frame contains no image, no objects. So it shows us nothing. So now it will have the ball here. The code will show ball. Next, it has a bottle upright position. We have to calculate the orientation. So this is a bottle upright position. So here it is having a bottle upright position detected by orientation detection code. Now this is a box upright. This is the code running as box upright. So after classifying the image of the object, the code will automatically send this to a serial caller, and the Arduino will control the signal. So this is how it controls the signal. So this is a board. This is how it opens. This motor is working now. It is rotating. It's closing its grip to control the board. It's speaking as a board. Keeping it to the rest position. The arm will open its hands. This is how it picks a board. Now this is a box in the upright position. Opening the fingers and thumb. It's rotating. Now this is a board upright position. It's rotating. Now box in a horizontal position. So this is how the arm works. This is the Arduino code running behind the program. So this is our entire arm and its execution. This is our Arduino, our breadboard. So we have given a material like this so that we can have a proper grip of it. And this is our deep learning part where we have a camera. So that's our live demo. Thank you.
Thank you very much for the presentation and for the demo. We have some questions for you. And my first question is, what is the actual use case for this arm? Is it that a person without a limb fits this arm on his or her hand and can then grip and lift objects? If that's the case, then how do you issue commands? Like, for example, release the grip so that the object can be released, or turn the arm. So for a person who's wearing this, how are the commands issued?
Okay, So this arm is actually for amputee. That is like a person does not have a limb, a lower limb part. So this is being attached to a person who does not have a limb through this part. And the commands, now we are having a prototype here. So we have just passed the commands to pick the object through 30 seconds. Like if we have an IR sensor here, and if it detects an object, it will automatically opens the fingers and grip the object, pick it for 30 seconds, it will hold, then it will leave, and it will leave when it will be in the rest position. Like if we can get like this, it will automatically leave the object and the arm will be automatically opening his fingers.
Right. So that means you have usability issues. For example, if you're keeping your arm in at rest position near an object, it will grip it without your intention to grip it. And even if you want to hold it for more than 30 seconds, at 30 seconds, it will release it.
Yeah, because this is just a prototype. So we can't have the myoband availability. We have a thing called myoband in order to control our internal bionic signals. So if we can have that, we can automatically control through our intention. But now it is not available anywhere because it is not available in the online stores and all. So because of the absence of this bionic myoband, we can't control it to the bionic signals. But if we can make it to a product, we can customize the myoband and we can build it. So that's why we cannot control the arm with the bionic signals of an human.
Now, for instance, if it's a person with another one arm intact, there could be some way of controlling it with a switch or something like that with the other hand, remote control, because the brainwave interpretation is too iffy. We are not at a level that we can really implement that for issuing commands. But couldn't you think of a more simpler arrangement whereby with the other arm or some other part, maybe moving your head, you can control this?
Moving
your head.
Or I think some voice commands that also will be better.
Yeah, voice commands also are possibilities.
Yeah, now we are actually trained only with camera because image capturing is done through deep learning calls and all, but we does not recognize this voice and all. Because if we can recognize it through voice, it will be just like a robotic arm. We have to make it through like a human arm. That's why we doesn't have that voice recognition part here now.
Okay, before we move on to the other judges, one last question from me. What if it encounters an unknown object?
Yeah, it definitely pick an unknown object because at first we doesn't train these three objects. We have trained different objects, but it started picking different types of objects. But the only thing is it has to be it has to have some groups on the shape. And also the similar shapes. Like we have trained for different bottle, but now it's able to pick this one. We actually trained with this bottle. It can easily pick this bottle now, but now it is able to pick this one. So that means we'll be able to pick objects which is having similar shapes. That's what we have put the pictures in the presentation. We have different objects to pick by this arm.
Okay, thanks. The floor is open for the other judges.
Yeah. Hey, see, I've been having very keen interest in PCI, right? And when I got a PCI device about 8 years back, right, and I let my son use it about 6 years from now, he could actually control games by using that single electrode BCI. So BCI is a potential way to actually get this running well, but then you need to bring in sophisticated algorithms to do that, right? And you need the arm to be learning from what senses, what kind of neural impulse are generated, etc. And you have APIs and all of that for these devices. It's worth exploring that, right? And my question is, you have computer vision, right? Either I missed out, or or actually there's a better use case in this particular product that you're trying to develop, where computer vision is playing a good role. What is that important role that computer vision is playing in this particular case? So it's a prosthetic, right? And how is computer vision coming into this picture? If it's a robot, right? Meant to, let's say, cook or something, and then it says, hey, pick the tomato, etc., etc., that makes sense, right? There's a reason for a machine to analyze what the object is. But this is a prosthetic arm, right? And the person knows what the object is, right? And because this person's half arm is only, he also knows how to get it closer to the object. What is the actual purpose of computer vision in this?
So computer vision, we are mainly using for image classification and the object orientation. So we have the code.
What is the purpose? I'm not bothered about the code. It is easily doable, right? What is the utility of computer vision in this prosthetic arm? You understand what purpose does it serve? The human can see. He can also move. It's half the arm that you're talking about. He can get the hand going closer to the other object, right? But where does computer vision come into the picture?
So actually, this computer vision is actually it's to understand a feature or a scene or a part or something like an object in a scene. An image captured by a camera can have many objects or many things
Okay.
which
So
in,
can I say it is more for gauging the width, how much should the pressure be, etc. Is that what you're doing?
yes, sir, to analyze its shape, its weight, and to get the it's
But
boundary.
object detection is not sufficient for that, isn't it? Object detection is not sufficient for that, because it just only identifies the objects. It doesn't have details of the size, shape, texture, right? How is it going to serve? Is it just the initial stage that you're trying to experiment with, or have you planned to do something else? You're getting my question? Do you get my question? So
Yes,
the
sir.
shape aspect is not here, right? And
Yes.
how much pressure should be applied is not here in your CNN model, isn't it?
So we have a 4 layer of CNN model because we have 3 convolutional networks and layer and 1 dense layer. So here we actually have this simple camera to capture the image, which may have different types of objects in the same image to capture and boundary to have a boundary around the object.
Yes,
Yeah, around the object. We need this computer vision techniques, and also we have 3D cameras. 3D cameras like detecting RGB values to detect the orientation like codes, coordinates, and everything. And it will also calculate the weight of the object. So we are actually trying to make a 3D camera because of this cost. We can't have that for this process.
So if it is 3D, if it has a depth sensing camera, it serves some purpose, right? Like what I was saying, like what is the shape, what is the size? This doesn't. Your current thing doesn't, right? It doesn't serve any purpose in this scenario, is what I think, right? But I'm finding it hard to figure out what it is, right? If you have a nice explanation that tells, hey, there is a real use of computer vision in this using 2D. So we're talking about monocular cameras, right? And you're talking about just ordinary snapshots, frame by frame. You're doing analysis and saying where in the scene an object is there, right? So if there is a good explanation, I think it's very directionally it's good, right? Maybe you want to experiment deep learning, etc., and then maybe go on to 3D cameras and stuff. Like if that was a rationale, I think it's a nice thing to do that.
For creating a big data set, we need a big video which is to be cut through frames. So this is only can be done through computer vision techniques. So that was the main aim which we started through computer vision techniques because we need data set. And the data set of the object which we are making is to be made by ourselves. So we started making data.
That's not true. ImageNet has 14 million pictures of all objects, right? And all sorts of objects. So you don't have to worry about that. And there are models that are already built. You don't even have to build the model. It can detect most common objects, right? And one other problem, right? So you said 2 objects are there, right? And you had the Kinley and this bottle that you show in the screen, right? And you said what it learned from the other one, it was able to use it here. Now, when you have 2 bottles, what happens? You have a Kinley and this one, which will it pick? You're getting the problem. It's called a false positive problem, right? And
so the user will be thinking which he want to pick.
yeah, then
Like,
you
pick that.
Then there's no reason for having computer vision there, right?
So, but the arm has to make classified object grip nodes control to pass through the fingers only through camera detection. So if the person want to, if these both objects are together, if the human want to take this object, the camera will be placed towards that object. So that the camera vision, computer vision technique can classify that particular object and then classifies the control gift nodes and pass through the fingers to pick out.
Okay, maybe I'm missing something because
Yeah, so I think what they're trying to do is to automatically pick an object up if the object is right in front.
Yeah.
If the object is somewhere else, it will not attempt to pick it up. But if the object is right in front of the arm, it will assess the object and then automatically calculate the grip required and the movement required and pick it up. But as of now, the command to release it is still not done. Releasing is a separate step that needs to be worked out, maybe using this BCI, the brain computer interface, or some similar, or a voice or some other remote control.
That's true.
Yeah. So, Neelakandan, do you have some more questions?
Actually, it's not a question. What I think is that from the given the use case, it would have been better if it is not going for any computer vision, but just to pick up with some motion or voice command, whatever plays in the camera is okay to know whether that specific anything is there in front of it, but the computer vision as of now it seems to be an overkill and doesn't serve any purpose. That's what I think. Okay, it's only a comment. That's it.
Thanks, Neelakandan. Another thing we can probably think of doing is to provide or to gather feedback from the grip. If you grip too hard, then the object might break, like a plastic or whatever. So if you get feedback from it and then use that as in a loop back mode, maybe you can do something sensible with the feedback. In any case, thanks for this work. I think it is very interesting and it is also socially relevant because of the fact that there are a lot of amputees. So thanks for your presentation, and we will get back to you.
Yeah.
Thank you so much.
Continue the good work. I think it's a
Thank
very
you.
nice one. You should continue. There are very few people who would want to get into this. It's a very nice one. Please do.
That was the main motto of our project.
Thank you so much, team. Now you may leave.
Thank you.
With this, we have reached the end of today's evaluation schedule. I would like to extend our sincere thanks to the judges for taking a big chunk of their weekend to help us evaluate these projects. I would also like to thank the 8 project team that presented today. I hope our judges were able to throw some light into your projects and hopefully make it all the more perfect. Finally, I would like to extend a sincere thanks to the audience who stayed on till the end to support the teams and also to learn something new. I hope we were able to kindle some new ideas into the minds of many. Let us meet here tomorrow at sharp 9 a.m. to continue with the remaining presentation. Thank you all and have a nice evening.